All right, so welcome back to everyone. A very warm welcome to all of you, my dear students. A very warm welcome to all of you. So, guys, I'm hoping that you guys can see me and hear me properly. So, welcome to your very own channel, NEET Success Simplified. And to I am here to give one complete revision session of units and measurement. So, guys, we already have completed the chapter of units and measurement, and now in this session, we are going to have a quick revision to this session. We are going to have a very quick revision to this particular chapter, and in this session, I'll be completing the whole of this. I shall be completing whole of this chapter in one run. Okay, so this is one short session. This is sort of a the one session in which I'll be covering to some extent all the topics that we have covered in this particular chapter of units and measurement. Okay, so guys, I'm your physics educator, Dr. Shankar Sir. Okay, and these are my brief introduction. So I have completed PhD and masters from Indian Institute of Technology, Roorkee. Okay, I have qualified the Vinika. I'll be completing the entire syllabus by the end of March, most probably. Okay, because see, on 5th May we have the examination, so you need at least a month to revise also. Okay, so this first chapter was a bit lengthy chapter, but from the next chapter they are not that lengthy chapter, so I'll be starting with kinematics probably from tomorrow. Okay, and very soon kinematics, that is motion in 1D, motion in 2D, and this law of motion. So they are very interrelated topics, so we'll be doing it very quickly. Okay, so we are planning to complete your entire syllabus by the end of March, including this biology and everything. Okay, okay, right. So shall we begin the session? Yeah. Okay. So I was introducing myself, but I reckon that after all these sessions, you guys know me quite well. So basically, let's continue. Okay. So guys, in this first chapter, okay, so there are, like, you can expect two questions from this chapter. Okay. One is, so Vinika, in this session we'll be having a complete revision of this first chapter, units and measurements. So in the updated syllabus, this is your first unit. Okay, and like vernier caliper, screw gauge are mentioned in your unit number 20. Okay, so in this session, I'll be completing the whole thing, give you a revision to whole thing, and there are detailed sessions to each and every topic. Okay, when you see this, all the playlist and all the sessions of this chapter. So let's quickly continue. Okay, we'll try to finish this as soon as possible. So the first thing we started to see in this particular chapter was about the physical quantities. Now in this session, I'll be refraining myself to discuss the things in much depth, but I'll be giving you a brief overview, like the question oriented. Okay. So physical quantities, we have learned that physical quantities were of three types. Okay. One was fundamental quantities, other one was derived, okay, which are derived from the fundamental quantities, and that is one is supplementary, okay, that is supplementary quantities. So as we say that, like the English language, we have some basic alphabets, and from that alphabet the whole language of English has been made. Now in the same way, the whole of this physics, okay, we require physical quantities for interpretation of various laws of physics that we are going to see in the future chapter. Like in the second chapter, when we are going ahead, so we are going to see the phenomena of equations of motion, right? Okay, so equation of motion, what it interprets a physical phenomena. Okay, like something has displaced from this point to this point. What could be its possible its velocity? What it could be possible acceleration? So basically, to understand any physical phenomena, we require some language, and this physical quantity gives language to the subject of physics. Okay. Now, the first one is the fundamental quantity. So we have how many? Seven fundamental quantities. Okay, what were those? The length we had, mass we had, time we had. So these three are the most used one, because you see most of the question they ask you about these three when we come to the dimension. We want to represent, or we have to represent the dimension in terms of these three. Then we have this temperature. Then we have this current. We have the luminous intensity. Okay, luminous intensity, and lastly we have the amount of substance. Okay, so guys, in detail, if you want to see everything in detail, you can go back to the first session of this particular chapter, units and measurement 1. You can find it on our channel, Need Success Simplified. So in this chapter I'll be quite quick. Okay, so these are the basic quantities. So I'll be writing their units here. Symbol, so this is length, we know it is meter. Mass kg, time second, temperature Kelvin, current ampere, luminous intensity candela, amount of substance mole. So these are the symbols of their unit. Okay, we know the units of it very well. Right, now how many derived quantities are there? The live student, do you want to answer something? How many derived units are there? So I can say countless number of derived units are there. Okay. What are the derived units basically? So the units which are derived from the fundamental quantity. Okay. So any physical quantity which is something more to the fundamental quantity, it can be fundamental quantity used multiple times. Like for example, area. So area is what? It is L square, length is square. Okay, length into width. Width is also sort of a length, right? So when we say this area, so this is a derived quantity because it is having a unit of meter square. That means something more to the fundamental quantity. When in a physical quantity there is simply something more to the in the fundamental quantity, when there is simply something uh, more than the fundamental quantity, it is called a derived quantity, like meter, area, volume. You can't just name them all of them because there are so many that you can never end up naming the derived quantity. So the simple thing is, whenever something there is other than the fundamental quantity in any quantity, okay, in any quantity, we call it derived quantity. Be it area, be it volume, it can be velocity. Okay, it can be velocity. Velocity is what? Change in displacement upon change in time. So meter per second. That means a combination of fundamental quantities are used. So one fundamental quantity is more is if it is more it is if it is used more than once to explain or to interpret some physical quantity, that is a derived quantity. Okay, or a combination of fundamental quantity might get used. Right, combination of fundamental quantity. Okay, like velocity, it is change in displacement upon change in time, that is meter per second. So two different fundamental quantities are getting used. Energy, force, all these are fundamental quantities. Like for example, force is mass into acceleration. Okay, so for mass we have the unit of kg, and for acceleration we have meter per second square. Okay, so this is a derived quantity. Okay, because it is using multiple fundamental quantities. Do you agree? Yeah. Okay. And moreover, this is also known as the Newton. So in general, this whole thing we call as the Newton. So the Newton is a derived unit. It is not a fundamental unit. Fundamental units are these seven. I hope this is clear to everyone, and we'll keep deriving some units, and so on. Now, please understand this. This supplementary unit is something very special. Okay, so there are two supplementary units. One is plane angle, or we call it only angle, and there is uh, there is solid angle. So one is plane angle, one is solid angle. Okay, the unit of the angle is radian, and the unit of solid angle is steradian. Okay, so any live student can tell me what is so special about supplementary unit. If you have followed my lectures, you might be knowing. If you haven't, then that is okay. Just any live student want to tell me what is so special about the supplementary unit. Okay. And in general, what is the meaning of supplementary? So this is something which is supplementary. That means it is extra to something, right? So neither it is fundamental, neither it is derived. It is categorized in some other, segment. So what is so special about the supplementary content? Anyone? Anyone? what is so special about the supplementary quantity? Okay, so see, one very special thing about the supplementary quantity, that these are the only quantities. These are the only quantities. These are the only quantities which has units. Okay, which has units, because the unit of SI unit, and obviously we are talking about, so the SI unit of angle is radian, the SI unit of solid angle is steradian, SI unit of solid angle is steradian. Okay, so these are the only quantities, guys, the which have the unit but no dimension. It do not have any dimension. So these are the only quantities which are having the unit. So they have the unit, that is radian, and for solid angle it is steradian. So they have the unit but they do not have any dimension. So this is something very exclusive. Okay, very like breaking news about the supplementary unit. Okay, okay. Now what do we mean by dimension? Let's come to that. So basically, if I define the dimension, okay, so we understood that all the physical quantities, mostly that the derived quantities, they are somewhat formed from the fundamental units. Okay, somewhat formed from the fundamental units. So dimension in physics basically give you a one way, like you see the dimension of something and you come to know that how many fundamental units to what power. Okay, we understand the power of something. Now you like, if physics is an organization, okay, so there are positions to organization. Like you enter into some organization, you say, okay, you are the CEO. So you understand what would be the power of that person in that particular organization. Now, same way in the world of physics, dimension is something. By seeing the dimension of physical quantity, you can understand that what power is given to what fundamental quantity. Okay, so what is the dimension? So basically, if I define it, dimension, so these are the powers. Okay, very important. These are the powers to which fundamental quantities are raised. These are the powers to which fundamental quantities fundamental quantities are raised are raised in order to in order to express any derived quantity. Okay, so if you want to express any derived quantity, okay, you can give powers to the fundamental quantities, and through that you can express any of the derived quantities. So one very important, so this is the mostly the question is asked from here. If you see the NEET PYQs, so see Zone 1, if I say from where, like from the previous year analysis, Zone 1 questions. So Zone 1 questions means what are the questions from here? So basically they ask you in this kind of question that you need to derive unit of some quantity, some physical quantity PQ, okay, or you may need to find dimension of some physical quantity. You may need to find the dimension of some physical quantity. So it is obviously endless. It is obviously endless. So we'll find two, three. So if you want to see how the dimensions of any physical quantity is found and you want to find multiple physical quantity, you can go to the detailed section, okay, and you will get everything. Okay, but here I'll be quite quick. Now see, I'll be writing the dimensions here itself, not the dimension but the representation, because dimensions are the powers to which a fundamental quantity is expressed. Okay, so these are the powers. Okay, power to which fundamental quantities are raised. That is power to the fundamental quantities like length, mass, and all this. Okay, now I'll be representing them like this. Okay, we shall be firstly see the representation. So the representation to the length is in when we want to show the dimension. So it is like this: L M. Okay, time for time. This is T. So these are the most prominently used. Temperature we show it normally by Kelvin or sometimes by theta. Okay, so see, K is the term which is very commonly used to express many constants. Okay, many constants, right? So these constants, when we are expressing, so K like thermal conductivity. So sometimes we get confused with the constant to the to this Kelvin representation. So from K, okay, okay. So the temperature unit SI unit is Kelvin, right? So this is K or theta. For current, we use A or I, depends upon us and the situation. For luminous intensity, we use CD, okay? And for amount of substance, we use mole, right? Okay, this is the general way to represent these quantities. These are the, okay, so I think mole goes out of the box. I have written it a little below, no problem. So I'll write it here, mole, okay, within the bracket. Okay, so this is how you can represent their dimension. Now, please observe this. So, dimensions are which the are the powers to which fundamental quantities are raised in order to express any derived quantity. So, it is very simple. Now, please see. You can write the dimension of any physical quantity through its formula. You can write the dimension of any physical quantity through its formula, or you may write the dimension. You may write the dimension you may write the dimension through its unit. So if you know the unit of any physical quantity, you are good to go to write the dimension. If you are if you are knowing the formula of any physical quantity, okay, then you are good to go to write the dimension. Okay. So anyway, by any of these ways, you can write the dimension, and you can move in the reverse order also. Okay. Like if you know the dimension, you can write the formula, you can write the unit. Okay. This will be the second segment of the chapter from where partial sound is not clear. अच्छा sound clear नहीं है. I'll just look into it. Just a moment. Okay. I'll just see to it. हाँ ठीक है. अभी अभी ठीक है हर्षल. Thanks for telling me. अभी ठीक है my friend. Is it fine now? हर्षल मेरे भाई. Is it fine now? Or shall I speak a little more louder? Yeah. Is it fine now, my dear? Hello, Sam. Okay, it is fine now. Okay. So I was talking about the dimensions. ठीक है, dimensions के बारे में बात कर रहे थे. So we were talking of the dimensions. So see, these fundamental quantities are represented. Yeah, hello Sam. Hello. Welcome to the session, my dear. So we are having a complete revision with this particular chapter of units and measurement. Okay. So as I was saying, so we want to represent the physical quantities in terms of dimension, which are the powers to which the fundamental quantities are raised to express any physical quantity. So you can take of any quantity, any physical quantity that comes in your mind, like area. So if you know the unit of the area, hello Prakash, if you are knowing the unit of the area, okay, or you are knowing the formula of the area, either way you can solve. So what is area? Area is L into B. What is its unit? It is meter square. Okay, so B is also sort of the length now. So meter square, if you represent it in the form of dimension, so what will you write? The dimension of area, you would say L square. Okay, L square. Okay, so the area can be represented when the length is raised to 2 power. Okay. Okay. So what is the dimension? So I can write it like this also. Na? M0, L square, T0, or and all the 7 fundamental quantities. But what happens in general, we represent most of the physical quantities in terms of MLT. So what is the right way of saying the dimension of any physical quantity? So I must say that the dimension of area in mass is 0. Okay. The dimension of area in length is 2. The dimension of area in time is 0. And same way the dimension of area in any all the other fundamental quantity are 0, but generally they are represented in MLT format. Okay, so this is widely accepted way of representing the dimension M0, L2, T0. Like this, in a glance, you can check that what is the area and what is its dimension in several fundamental quantities. Okay, okay. I hope it is fine to everyone. Same way, if you want to represent the velocity, there are n numbers of fundamental, n numbers of derived quantities which you may want to represent here. So velocity is what? So we know the formula. It is change in displacement upon change in time. Okay, so the unit is meter per second. If you know the unit, if you know the formula, you can get. So there is nothing of mass, so we can raise the mass to the power 0. So we have 1 meter. So meter for meter, that is the fundamental dimension of L. And what is this second? So it is upon time. So if I take the time to the numerator, it will be t minus 1. So what is the dimension to the velocity? Sir, it is going to be m0 l0 t to the power minus 1. m0 l0 t to the power minus 1. Sorry, l1, not 0. Okay, m0 l1 t to the power minus 1. Okay. Okay, so what is the dimension of velocity? What is the right way of saying it? So the dimension of velocity is 0 in mass, is 1 in length, and it is minus 1 in time. So same way you can get the dimension of anything, no? Okay. So these are, I was talking about, these are June 1 question. In these questions, you will get to see the questions in which physical quantity, units of physical quantities are asked, or dimension of physical quantities are asked. Okay. So we can find n number of physical quantities dimension. Okay. Do you want to name something? Let's do for force. Okay. What is the dimension of the force? What is the dimension of the force? Anyone? The live student? The live students may tell me what is the dimension of force? बताइए. Herschel, Sam. Anyone? Please tell me, guys. What is the dimension of force? So if you know the formula of some physical quantity, if you know the unit of some physical quantity, you can derive it. Okay. So these questions are very much asked in the examination. Anyone who want to tell me the dimension here? Yeah. Anyone? Anyone? Very good, Vinika. So very simply we can do that. So force is equal to, we know, mass into acceleration. So if it is mass into acceleration, what is going to be the unit for mass? It is kg. For acceleration, acceleration is change in velocity upon change in time. So it is m second square, meter per second square. Okay. Okay. Or you can write the dimension directly from unit, you can do, from the formula you can do. So for mass, it is going to be m. Okay, that is kg. For meter, there will be L, and for second square, it will be T minus 2. And it is always advisable, see, it is advisable that you memorize this. Why, sir, we need to memorize this? Because, see, force is a very important parameter, na? Very important physical quantity. As far as the physics that we are going to learn is concerned, there are so many quantities which are related to it. Okay, so same way you can find many ones. So energy, okay, work, torque. So there is one kind of a question they are asking from the zone 1. Zone 1 questions are those which they are asking, Prakash, not minus 2. Why not minus 2? See how we are doing it. So we have kg meter per second square, right? Mass into acceleration. So for kg, I am putting one m. For mass, we represent it as m. For meter, that is the length. So we are representing it as L. And second square. So you can write m for kg. There is mass m. Okay, yeah. Oh, MLT minus 2. So that is the same thing I have written here. No? I think you have written something different. Okay, let me come to the next one. So guys, there is one kind of a question they are asking, that which of the following enjoys the same units or same dimension. Okay. Okay. Now please understand this. The quantities which have the same unit have the same dimension. Okay. Have the same dimension. So what is energy? What is work? What is thought? Mathematically they all are maybe different. They represent something different, like energy can be having different forms. Work is some form of the energy. Torque, when the force is applied to rotate something, right? But they all have the same unit, Newton meter. Do you agree to it? Yes or no? They all have the same unit. Force into some distance, right? Force into some distance. So all of them having the same unit, that is Newton meter, and sometimes you also know it as watt. Watt is also a derived unit. So what is going to be the dimension of all these? So sir, Newton, sir, memorized. We have memorized it. So it is MLT minus 2. And there is one meter mode, that is length mode multiplied to it. So it is going to be ML squared T minus 2. ML squared T minus 2. I hope it is fine to everyone. Now, same way, if you want to find the dimension of pressure is stress. So both are mathematically, I'll tell you, force upon area. Although they are different, they are not the same thing. Okay, they are not the same thing. So, but dimensionally they are same. See, physical quantities may be same dimensionally, but they may represent something different. Like there are so many differences in pressure and stress. Can you tell me two three difference between pressure and stress? Anyone? The live student? Anyone? What is the difference between pressure and stress? Sir, we don't know it. It's okay. Okay. Pressure is a scalar quantity. Stress is a tensor quantity. Pressure is external force per unit area. Stress is internal resisting force per unit area. There is no device in the world which can measure the stress directly. For pressure, there are so many devices: Borden tube pressure gauge, diaphragm, bellows, manometers, right? Okay. Moreover, pressure has no limit, stress has a limiting value. So there are so many differences. But mathematically, formula wise, if they are same, that means they enjoy the same unit. They enjoy the same unit. So hence they will be having the same dimension. You will be seeing quite few more also, like Young's modulus, like shear modulus, like bulk modulus. So all of them are going to have the same unit. See, remember, simple thing. The quantities which have the same unit have the same dimension. Okay. Okay. Now please tell me the dimension to it. What is going to be the dimension of these? Can you tell me? Can you tell me? Can you tell me? Anyone? Vinika, Prakash, Sam, the live students. What is going to be the dimension of it? Very good, Vinika. Wonderful. Okay. So how we can do it? Prakash, your answer, my dear. So what is going to be the dimension to it? So see, in the examination, we have to be very quick, right? There is 70 seconds to each question. I hope you know this, no? So when we have 70 seconds, there is no time to do it beautifully, no? We have to do it like we just have to reach to the right answer. So for Newton, we remember the dimension, and for meter square, it is L square. So it is going to be ML minus 1 T minus 2, right? Ah, okay, so see, these kind of a question they are asking very frequently. Okay, in no time you have to give the answers, right? In no time you have to give the answers. Please go for it. See, speed is the key. Are you getting my point? Speed is the key. If you have all the time in the world, okay, if you have all the time in the world, definitely you are going to answer it. Speed is the key, my dear. Please go for it. What is the answer to the first one? What is the answer to the first one? What about you? What about the rest of you? So these all are PYQs of NEET. Okay. I'm just randomly picking. Okay. Just randomly picking a few questions. Ah, yeah. Please try this. Please try all these three. See, I am also like, we are not here to make a very good copy, no? Right? Wonderful. Prakash, Sam, please answer, my dear. Please answer. Very good, Prakash. See, answering is very important. So, see, the first one. Which of the following groups have quantities that do not have the same dimension? Achha, one more advice is here. In NEET examination, you must be able to read the question very quickly and process in your mind. Okay. So, which one of the following groups have quantities that do not have the same dimension? So, pressure, stress, they have the same unit. Velocity, speed, they have the same unit. Work and energy, they have the same unit. What is left? Force and impulse. What is force and what is impulse? So, we know impulse is force into change in time, right? So, this is going to be the C option. The dimension of universal gravitational constant. See, to develop the dimension, you must know the formula or you must know the unit. Now, here, one more point I want to mention. Not all the constants are dimensionless. See, if there is a constant like a number 2, 3, 4, 5, 6, 7, 8, 9, 10, it is having no dimension. See, any physical quantity, for it to be represented, there are two things. One is its numerical value, one of it is its unit. Okay, number has no dimension, pi has no dimension. Okay, so normally students say like this, the constant has no dimension. So there are constants which have dimension. See, simply, if any constant has some unit, like universal gravitational constant, like coefficient of viscosity, like thermal conductivity, like coefficient of thermal expansion, like Planck's constant, okay, these all, and there are many more. So these all which are having any constant which are having some unit, they have the dimension. So what is the formula of universal gravitational constant? Sir, if we don't know it now, we are going to see in the chapter of gravitation. So for time being, what you can do, if you just have started your preparation and you don't know the formulas, you can Google them. No worry. So F is equal to G m1 m2 upon r square. So F is the force, G is the gravitational constant, m1 m2 are the masses, and r is the distance between them. So from here you need to get the dimension of G. So right away start doing it from here itself. MLT minus 2. That is the force. Now this is kg, this is kg. M1 and M2 both are masses, so it will go m square here, and r square, that is going to be L square. R is the distance, so it is going, its dimension is going to be L square. This is going to be the dimension of G. So what it is going to become? It will be m minus 1. It will be L cube T minus 2. M minus 1 L cube T minus 2. So that is going to be the B option. I hope it is fine to everyone. Now, if you want to interpret, if you are from the dimension, if you want to think of the unit, what could be its unit? From the dimension, if you want to sort out the unit, so for M, this is kg, that is -1, L cube, that is meter cube, and T minus 2, that is second to the power -2. Okay, but this thing has a limitation. What limitation? Because if in anything, if there is a radian or something, like if there is an angle of something, like if you say, what is the unit of angular velocity? So it is radian per second, but its dimension is T minus 1. Are you getting my point? Because radian, angle supplementary quantities are those quantities which are having unit but they do not have dimension. So not always the funda of the dimension to unit works. Are you getting my point? हमेशा डायमेंशन और यूनिट का फंडा काम नहीं करेगा. देखिए जहां पर भी रेडियन पर सेकंड की यूनिट होगी, रेडियन पर सेकंड स्क्वायर की यूनिट होगी, मतलब रोटेशन वाला मैटर जहां पर भी होगा, wherever it is a thing in which rotation is required, like the torsional stiffness, if you try to see the torsional stiffness unit from this phenomenon, you are not going to get it. You are going to get that Newton meter only. Are you getting my point? You are not going to get the radian thing. Okay, so it has some limitation, right? Now, moving to this, please try to find the third question. Yeah, please go for it. Please go for it. I'm very sure we can do it. Please try. Please try. Any answer to this third question? The force on the sphere. The force on the sphere. Anyone? Seems incorrect, my dear Vinika. Seems to be incorrect. See, I'll do it. The force on the sphere of radius A is moving in a medium with velocity v given by force F6 pi. So, third question, F is equal to 6 pi. And what about the remaining of you? 6 pi eta A into velocity. So, you need to get the dimension of this eta. So, let me convert it into F upon 6 pi A into V. So see, 6 pi has no dimension. This is a number, no? It is a numeric value. When something has got some numeric value, it has no dimension. Now, what is the dimension of this force? So dimension of this eta. So I'm not writing anything, just I'm going it like the way you must do in your examination. We don't have much time there, no? MLT minus 2. 6 pi has no dimension. A is the distance. Now, please read the question. You have to read it in hurry also. I'm not saying that, but you have to read it right. Now, many students confuse this A with acceleration. And it is not acceleration, it is a distance. It is the radius of the sphere. Right? So, it is a radius, so it is L. It is L, and for V, it is LT minus 1. So, how much it is going to become? It is going to become M L minus 1 and T minus 1. Right? M L minus 1, T minus 1. So it is going to be the D option, right? It is going to be the D option. So what is the mistake that you have made, my dear? Please answer me. What is the mistake you have made? Done, is it? Then have you got your mistake? What is the mistake you have made here? Right. Understood? Now, can I say, now similarly, you can solve many questions, okay? In the previous videos, so if you see the videos of the dimension on this channel, I have derived, I think, more than 37, 38 physical quantities dimension. So if you want to check, you can go and check there. We have solved some questions also in the previous session, okay? Okay, so I think June 1 question you will be able to do. How to get the dimension, how to get the unit, okay? They may ask you to get the unit also. They may ask you to get the dimension also. I hope you are going to deal with it. Now let's move to the zone 2. Okay, so in zone 2, of this chapter, they are asking you the question using dimensional analysis. Okay, so this dimension has much of the use. Okay, dimensional analysis. So basically, it is based on Vinika, yes, in further chapter. Okay, like in this chapter, most of the thing we already have done. So and also the questions are so many, like a lot of discussions will be required. Okay, so there will be DPP. Okay, and we'll be doing the previous year questions also, right? And also, see, I'll tell you one thing, Monica. See, I admit I'm not a perfect person, right? So you keep suggesting to me, like, sir, I want DPP. I'll be more than happy to provide. Sounds good to you, right? I am, see, physics is one kind of a subject. I tell you, it is such a big subject. Are you getting my? No one in the world, if anyone is claiming that he knows everything of physics, he's lying to himself and to the world. I'll tell you very frankly. I have done PhD, right, from IIT, Indian Institute of Technology. I admitted here that I don't know physics. If physics is this, I know like this only. Okay, so we can always improvise on the basis of your suggestion. If you say that, sir, I'll be requiring DPP, I'll be providing you. Okay, okay. So we'll be keeping on, adding things. Okay, right? Sound good? Yeah. Okay. Yeah, I'll do it. I'll do it. No worry. Okay. I think the PDFs of the previous sessions are also uploaded. I told the team to do so. If not, I'll check to it. I'll check. No worry. Okay. This session PDF you are definitely going to get, right? Okay. So let me come to the point. Now, dimensional analysis. So the June 2 questions are getting asked from the topic of dimensional analysis, and basically it depends upon the principle of dimensional homogeneity. Principle of dimensional homogeneity. So see, it is a very, very simple thing. It is a very, very simple thing. See, we do it, everyone does it in their normal life also. So if I say that I have 20 rupees and I have given you 5 rupees, so how much rupees I am left with? How much rupees I am left with? So you will say 15 rupees, right? Okay. See, simply only those quantities can be added or subtracted which have the same unit. Okay. So this is a common knowledge now. Like rupees will be added to rupees will be subtracted to rupees. Okay. Time will be added to time, length will be added to length, right? Okay. Do you agree to it or not? Okay, length will be added to the length. If I say 10 meter plus 5 seconds, you will say, "Arey sir, how it is possible?" Right? This makes no sense. Okay, this is what principle of homogeneity says. Okay, this says that only those quantities can be added or subtracted which has the same unit. First thing. Second thing, that if any equation is there, and there are few terms in that equation, okay, there are few terms in that equation, so all these terms must enjoy the same dimension. Okay, and if they are having the same dimension, they are having the same unit, obviously. So this is having whatever dimension this must have that dimension, this must have that dimension. Nose maker, okay, I'm sorry for that bit. Okay, you may choose to watch it, you may not choose to watch it. Okay, up to you, right? So we are doing it in a pace today. Okay, so principle of dimensional homogeneity. So in this case, what happens, the dimension of each of the term must be the same. Okay, dimension of each of the term must be the same. Like this is having many applications. Okay, so what kind of a question are asked from the dimensional analysis? So they are type 1. Okay, what are this type 1? So the type 1, they ask you like v is equal to a plus bt. Now give the dimension to a and b. What is the dimension of a and b? This is again, I see that this is the NEET question. Okay, or we have v is equal to v is the velocity, v is the velocity and t is the time. Okay, v is the velocity and t is the time, right? Can you please tell me the dimension of a and b? What is the principle of dimension homogeneity says? So if you are having an equation, the terms which are at left hand side, the terms which are on right hand side, they all must have the same dimension, because obviously only the terms which are having the same dimension can be added, subtracted, and the result must also come into the same dimension, right? Okay, so type 1, in which they are asking you the dimension of few quantities. Can you tell me the dimension of here? Very good, Vinika. Very good, Vinika. What is the dimension of B then? What is the dimension of B then? So how can we do it? How can we do it? So simply we can write like this. Sir, the dimension of A must be equal to, so what are the terms? One term is this on left hand side, this is one term, this is one term. Okay. Okay, so the terms which are separated by the sign of plus or minus, they are called as one term. So what is the dimension of A? The dimension of A is equal to the dimension of the term on left hand side, that is, it is equal to the dimension of V. Okay, so this is the first question we are doing like this. Very good, Vinika. So how we can do it? So dimension of A, what is the dimension of V? So dimension of V is meter per second, its unit, so it is LT minus 1. So the dimension of A has to be LT minus 1. Now similarly, the dimension of B, what is going to be the dimension of B, sir? So first of all, the dimension of BT is going to be equal to the dimension of V, right? So we can do it. So what is the dimension of this T? This is also a physical quantity. And what is the dimension of V? So V is dimension of V is LT minus 1. So this T goes to the right hand side. So the dimension of B will become LT minus 2. This will become LT minus 2. I hope it is fine to everyone. Okay. Okay. So this is what the formula. This is U plus 18. We are going to see in the next chapter, mostly by tomorrow. Okay. Now let's do one more question. So x is equal to, let's suppose we are having a plus bt plus ct square plus dt cube upon e plus t. So here we need to find the dimension of a, b, c, d and e. So can you get the dimension of a, b, c, d and e? Please go for it. Can we try doing that? Can we try doing that? Please try it. Again, this is the NEET question. So physics can also be very interestingly be done with the help of questions, right? Please go for it. Please identify the terms here. Please identify the dimension and give me the dimension of A, B, C, D, and E. My video and sound is fine, no? I'm also seeing your chairs in the mobile only. Okay, so that my computer works properly. Yeah, now very important. See, Vinika, at times what happens in the questions when they never mention x, y, you always consider them as length, okay, displacement, right? Whenever they say nothing about t, you consider it as time, if at all required, right? So x is displacement here, t is time here. P always you consider as velocity, V. Okay, if nothing is mentioned and you require that dimension, right? In some question dimension at all are not required of some quantity. Okay, please solve it. Please solve it quickly. Yeah. Try to do it. See, we have to take care of the time. See, two things are very important: time and accuracy. Right? Please go for it. I'm quite sure we can do it. Very good. Very good. I'm actually more interested in the dimension of E and D. Yeah, wonderful. And what about D? And what about the remaining students? Any other live students who want to answer here? You are most welcome. Yeah. So see simply now how to do it in exam. So this dimension is L. Okay. So the dimension of A has to be L. The dimension of this BT has to be L. So BT has to be L. So what we can write now, see the dimension of this T is T. So what is going to be the dimension of this B? So this is going to be LT minus 1. Then only it will become L now. Then only it will become L, right? This is CT square. This is CT square. So when this is CT square and the dimension of this whole thing has to be L, so it has to be LT minus 2 because this is T square, right? So the dimension of B will be LT minus 1, the dimension of C will be LT minus 2, right? So in this way also you can try it, right? In this way also you can try it, right? Or otherwise you can go by the conventional way, whatever prefers you. Okay. Now I am interested in this one. Okay. Now please understand this. Can I write the dimension of this D? So when the expression is slightly bigger, you can always choose to go by the right way. So the dimension of dp cube upon e plus t, it is going to be equal to the dimension of x. So what is going to be the dimension to it? The dimension is going to become L. The dimension is going to become this L. Okay. Okay. Now, please understand this. We just have understood. So only those quantities can be added or subtracted. This doesn't go with the multiplication and division, but only those quantities can be added and subtracted when they have the same dimension or the same unit. So E plus T. That means that E must have the same dimension as that of the T. Okay. So when E must have the same dimension as that of the T, the dimension of E must be T only, right? Now the dimension of this whole E plus T thing is T. Okay, so I can write it here. So D T cube upon T, because E plus T is going to be T only, and the dimension is L. So it is going to be the dimension is going of D is going to be LT minus 2. I hope it is fine to everyone, right? Yeah. Let's try one more question. So if P is equal to P naught e to the power minus alpha t square, this is one more case. So here you need to get the dimension of alpha. Here you need to get the dimension of alpha. Please try. Please try it. Please try to give me the answer to this. What is the dimension of alpha? Again, a NEET question. Sir, what is P? What is P naught? Now, in this question, P and P naught is not given, and you cannot assume it to anything, right? We don't know what is P. We don't know what is P naught. Just we know that T is time. Okay, T is equal to time. P and P naught we don't know. P and P naught we don't know. Please try to figure it out. Very very simple. Very very simple. Just one concept. Okay, just one concept. Please try. See, in this session, I'm only covering the key concepts. If you want to go into detail, you can go back. There are detailed sessions on this chapter over there on this channel. You can go and watch them. And obviously, you are going to have a proper insight. But as I said, this is a revision session. Okay. And this is the very big chapter as well. Any answer? Any answer, my dear? Anyone? Wonderful. Now, see, very, very simple it is. Very, very. Only one key point is there that this whole thing has to be dimensionless. See, e to the power something. When some quantity is in power to something, it is going to become a number, right? E to the power minus 2, it may be it may be e to the power minus 10. So whatever it would be, it must have to be a number, because unit in the power makes no sense. It is not existence. Okay, so what we can say, we can say the dimension of alpha t square minus alpha t square or only alpha t square is the m0 l0 t0, because it is dimensionless. It has to be a number. So from here we can get the dimension of alpha, and this is going to be equal to m0 l0 t to the power minus, right? So similarly you can deal with the all the any question in which something is having the power e to the power something or like that. Now same way you can deal with the sine cos function also. Let's say y is equal to a sine omega t sine omega t minus kx. Okay, kx. So t is the time, y x is the displacement, and y is also the displacement. Okay, okay, okay. So here how you do it. How you do it. So I'll do it. I'll do it to save some time. So basically, sine inside the sine, what it would be. So inside the sine, obviously it would be some angle, right? Obviously it would be some angle. So this is some angle. This is also some angle. Angle is the only angle supplementary units. So these are the only quantities which are having units, but they do not have any dimension. Unit तो होता है, dimension नहीं होता है. So these two are angle only. So when these two are angle only, they are dimensionless. So the dimension of omega t, it is going to be m0 l0 t0. So omega, it is going to be m0 l0 t minus 1. Similarly, this kx, what is the dimension to it, sir? m0 l0 t0. So what is the dimension to k? So it is going to be x is the dimension. What is the dimension of x? It is going to be L. So it is going to be m0 L minus 1 t0. Right? Okay. Yeah. Very simply. Very simply. Yes or no? Please answer me. Yeah. Very simply we can do like this. So when there is something in the sine thing, in the cos thing, or e to the power something like that, you are going to be able to deal with it. Okay. Yeah. So these were in the zone 2. The first zone was we have to find the dimension of some physical quantity. We have to find the unit of some physical quantity. In zone 2, there are a few types of question. The first one was finding the dimension of using the dimensional homogeneity, finding the dimension of some like variables which may be given in the question, like that, right? Please tell me if you agree to it. Yeah. So one more use of it is checking the correctness of the formula. See, there is one more use that you can convert the unit. So unit conversion we are not going to see. It is actually very lengthy, and we can convert the unit by ourselves only. Like kg, if it is to be converted into gram, meter to centimeter, we can do it in ourselves, and that is the way to do it. But dimensional analysis can be helpful in doing that also, but conventional way. In competition, I don't prefer that. Okay, I don't prefer that. Okay, so one more use. So first type of question is like this, where you have to find the dimension of some quantity in the equation. Now the second thing is checking the correctness of the formula. Checking the correctness of the formula. So our formula can only be correct. Okay, so we can check the correctness of the formula using dimensional analysis on some basic level. We cannot do it on very high level, right? But we can do at some basic level. Okay, like for example, if I have to check this formula, R rho G upon 2s cos theta, okay, where h is the height, R is the radius, rho is the density, which is mass density. Okay, G is the acceleration due to gravity. S is the surface tension. What is surface tension? It is force per unit length. Okay, this is a property of fluid by virtue of which it tries to minimize its surface area. We are going to see it, don't worry. So theta is what? Theta is angle of contact. Angle of contact. Okay, I think. Uh-huh. No problem. I think you can guess all these things because sometimes I forget that I am also present in the video, so I'll keep writing. Now, can you check the correctness of this formula, whether this formula is correctly written or not through dimensional analysis? So we can check the correctness of the formula to some basic level, not at very advanced level. How so? By using the principle of dimensional homogeneity. See, in if there is an equation, the equation, the left hand side terms and the right hand side terms must have the same dimension. Okay, can you try it? Is it correctly written or not? Can you try it? Can you check it? Can you check it? Can you check it? Surface tension is, I said, force per unit length. So Newton per meter, no? This is the unit. Now the dimension you have to get. Force per unit length, my dear. Density is kg per mass density is mass per unit volume. So kg per meter here. Okay. So I admit that at this point of time, if you are starting your preparation, there's nothing to worry. When we are going to see the fluid side, we are going to have all this physical quantity. So this is the first chapter and it uses the formula of each and every chapter. Okay, from 12 physics also you can find the dimension of many quantities, right? Please try it. Acceleration, surface tension, all these things are there. This is, I'll tell you after you solve the question. This formula you are going to see in somewhere near capillarity. There is a phenomena of capillarity. You are going to observe there. that this formula seems to be like what? So see, we are using just the principle of dimensional homogeneity. The left hand side dimensions and the right hand side dimension must be the same. Okay. Then only there is any equation. And as I said, this is the common knowledge now. Right? Rupees is added to rupees. The final answer, when you are transacting in rupees, the final answer is also be in rupees, like that. Okay? Very, very simple. Please try. I think it's not correct. Okay. What make you think so? See, this is in the physics you can't like. अभी मैं बोलूंगा तो हर सर गुस्सा करें. This is not biology though. So there is nothing to think about. Like you don't have like there must be some backing up what you are thinking to. Okay, I'll come up with it. Don't worry. So now, if I say the dimension on the left hand side, dimension of left hand side, this is h, so it is l. Now, simply, if the right hand side have the dimension of l, then it is correct. If on right hand side the dimension is not l, it is not correct. Okay, okay. Now, please observe the dimension of right hand side. So right away we are going to do it. In the examination, don't write all this thing. Just start doing. So R is L. Rho is what? It is kg per meter cube. So ml minus 3. Okay. Then G, it is LT minus 2. It is LT minus 2. Okay. Okay. What? Meter per second square. Then we have this 2. What is the dimension of this 2? So it has no dimension. What is the dimension of this S? Sir, surface tension. It is mt minus 2. Sir, how come this is Newton now? So mlt minus 2 divided by meter. So L. So it is going to be mt minus 2, and cos theta, it has no dimension. It has no dimension. So what is going to be the dimension here? M will be cancelled out. So see, L, okay, and L to the power minus 3, mt minus 2. So we are getting L minus 1. Okay, yeah. Right hand side, I got L minus 1. So you get correctly only. So you have to be confident. Okay, that you have got the right answer. What is the problem? You know the process. So L minus 1 is the dimension. Okay. So right hand side dimension and left hand side dimension are not the same. So this formula is incorrect. Incorrect. It cannot be correct. Okay. It cannot be correct. Now, can you suggest the right formula to it? Just let's see if we can play with it. See, this chapter is also utilized. So see what happens. Physics have so many formulas, right? There is 2 books in the 11th. We have 2 books in the 12th. 4 books are there. So many formulas. Okay, there are 20 units in the as per the NEET syllabus. That those 20 units are made up of nearly 30 chapters of physics. So if we have so many formulas, so sometimes what I have seen from my experience, beta, that students forget the formula, so their numerator goes into the denominator, their denominator goes to the numerator, like they reciprocate the formula. Sometimes they get confused. So like this chapter is sort of a hack to it also. Can you suggest me the right formula? If this is not the formula, what could be the right formula? Possibly. Can you think of it? Yes. Don't worry. Just try to. Just try to evolve. What do you think? So now, please think in this way. Sir, why the formula is not correct? Because we are getting the dimension of L minus 1 in the right hand side. Now, if I reverse this formula, 2s cos theta upon rho gr. No. See, if I reverse this, simply, see this L minus 1. Okay, so if I reverse this, it will become L now. So basically, I have written this formula just opposite what it is actually. Are you getting my point? See, we are getting L minus 1. We needed L. So we just have to reverse it. Okay, so sometimes, see, this doesn't work at all the instances, but at times it may help you to realize the right formula. Okay, what I'm trying to say that let's suppose that we come up to the chapter of solid mechanics. Now, in the solid mechanics, you have written some formula, and now you are doubting whether this formula is correct or not. In a GP, what you can do, you can check the dimensions, okay, whether the formula is correct or not. Are you getting my point? So this will help you not attracting negative marks at times, and it will help you recalling the formula at times, right? Okay, are you getting my point? Now, if you realize one more thing here, see, we cannot check the correctness of 2 and cos theta. See, if this formula would have written like this also, this would be seems to be correct only if you use the concept of dimensional analysis. Do you realize that? This is the very limitation of dimension analysis, that you cannot check that whether this 2 is correct or cos theta is correct or not, because they have no dimension. So there's no way to check them from dimensional analysis. Do you agree to it or not? Okay. Like if this formula instead of written as 2 cos theta, if it would have written s upon rho g r, this would have also been correct from this. If it would have been written as 98 as tan theta upon rho gr, it would be correct like that also, right? So dimensional analysis has this limitation that this 2 cos theta, so something which has no dimension cannot be evaluated or cannot be checked for correctness by this way, right? Are you getting my point? So s is equal to ut plus half at square. Can you check the correctness here? So obviously, sir, we know this formula. Nobody is going to ask it in the examination because this is the equation of motion. So right away, just I'm trying to tell you the way. So what is the dimension here? L. Ut, velocity time. So velocity is Lt minus 1. This is t. So the dimension is going to be L. Then half has no dimension. A L t minus 2. This is t minus 2. So t2. So this is dimension is going to be L. Okay. Okay. So this equation is also dimensionally correct, right? But again, we cannot comment about this half, whether this is correct or not. We don't know, right? Now, please tell me this type 2 question, if they are asking you to check the correctness of some formula, will you be able to use it? Yes or no? Vinika, everything is clear till this point in this section? If you don't mind telling me that. Navada? Yeah? Wonderful. Now the third thing here. Let's come to it. So type 3 and the most important. Okay. From this dimensional analysis, you will see, very good, Peter. You are going to see these kind of the question in the most predominant way. So basically, this is where you are going to relate between, okay, this is between formulas or physical quantities. So how we can relate between physical quantities, that is also one of the application and very widely used application. Many questions are getting asked from this particular section. So how you can relate the physical quantities, how you can come up with the formula of physical quantity, that is also somewhat principle of dimensional homogeneity. So for example, let's suppose we don't know that force formula is F is equal to ma, right? So any quantity formula you can derive. So let's suppose force depends upon mass and acceleration, and you don't know the formula of force, so you want to develop one. Okay, so through dimensional analysis, though again some limitations are there, but through dimensional analysis you can come up with the formula of force. How can, sir? So force depends upon mass, so you can write like this: force is proportional to m to the power x, then force is proportional to a to the power y, because it depends upon mass and acceleration. So this is the process how you can start the question. How we can start, sir? So we can start by proportionating them, okay, with some variable like x and y. You can use p, q, r, s, t, anything that you want. Okay. So f is proportional to x, f is proportional to mass to the power x, f is proportional to a to the power y. Now when you equate, hello Kumar. So when you create the sign of proportionality, if you create with the sign of proportionality, it is going to be m to the power x, a to the power y with a constant of proportionality. So this constant of proportionality we can never get because it is having no dimension, right? It is having no dimension. So now here, how can we get the dimension of x and y? So again, we can use the principle of dimension homogeneity. How we can use the principle of dimension homogeneity? So what is the dimension of force? It is mlt minus 2. K is a constant, it has no dimension. Now m to the power x. So what is the dimension? M. Then we write the power x. Then a, that is lt minus 2 to the power y. Okay, to the power y. So it will become mlt minus 2. And we have m to the power x, l to the power y, and t to the power minus 2y. So you open up the bracket, you do like this. And afterwards, what you have to do, you have to compare the powers of the same basis. You have to compare the power of the same basis. So for m, see, m to the power 1 here, m to the power x here. So when you compare the power of the bases, we are getting x is equal to 1. Okay. Then if we are having, see, if we compare the power of the base of L, so y is equal to 1. And if you compare the power of this t, if you are comparing the power of this t, then this minus 2y is equal to minus 2. So again, you are getting y is equal to 1. So from here, if we put it back here, we are getting f is equal to k times m to the power 1, a to the power 1. Okay. But we cannot find the value of k through this analysis. Are you getting my point? There is no way. It has no dimension, so there is no way that we can get the value of k. So we can develop the relation between the physical quantities in this way, but we cannot find the constant of proportionality of or any constant for this matter. Okay, in this. So k, when you want to find, you have to perform some experiments. So when Newton Baba has performed some, he said k is equal to 1, so f is equal to ma. This is very famous formula. Force is equal to mass into acceleration, you know it, right? So this is the way you can develop the relation between physical quantities. And this is very, very asked questions. I'll give you some problems also, but let's do one thing. So let's suppose t is the time period of pendulum. T is the time period of oscillation of pendulum. So I'll just write time period. L is the length of pendulum. Length of pendulum. Okay. M is the mass of the bob. Pendulum we know na, right? Mass of bob, and we have G as acceleration due to gravity. So you have to relate all these physical quantities, right? Please go for it through dimensional analysis. Please try to do it. Please try to do it. Please try to do it. Let's see if we can do it or not. In the same way you have to do. There are many, many questions that are asked from this particular part. X is equal to 0 usage. So X, see, how would I be knowing that you have taken X on L or M or G? Vinika, I think you are getting it wrong. Okay, I'll do it. I'll do it. I'll do it. Don't worry. See how we can proceed. See, we'll do one more question for it. Don't worry. See, we say time period, three things are involved: time period, length of pendulum, mass, and G. So can I write it like this? So T would be depending on the length of the pendulum. Let's call it X. Mass of the bob. So if we write to the power y. So I'm writing them together. Then g to the power z. Do you agree to it? And if we let go of the sign of the proportionality, we can write k l to the. So what is the need of writing k now? We cannot find its value, although this is the right way to do it. But in the examination, rather than the right way, we need the right answer, right? So k l to the power x, m to the power y, g to the power j, right? Okay. Now the dimension of the left hand side and right hand side must be the same. So can we write this way? What is the dimension of t? It is going to be t. It is k. So k has no dimension. Leave it. L. What is the dimension? L to the power x. M. What is the dimension? M to the power y. G. What is the dimension? L t minus 2 to the power z. Okay. Okay. Now please observe. So m to the power y. So y is clearly 0 because here we can write it as m0 l0 also now. So we are comparing the powers of the bases. Okay. All the live students, we are comparing the power of the bases. So m here is the power y, here m has the power 0. So y is clearly 0. What is that? How it can happen? See, you have to trust the dimension analysis. So simply it means that the time period of pendulum doesn't depend upon the mass. What is the problem? No problem at all. Okay. Now let's see about this z or x. Now please observe. So can I write it as this also? Sir, L to the power x plus z, m to the power y, and t to the power minus 2z. So this is not going to make any difference here, right? Is it? No, sir. Now we are comparing. So when we are comparing, so x plus z is equal to 0 and minus 2z is equal to 1. So z it is going to be minus 1 by 2. And if z is minus 1 by 2, x is going to be plus 1 by 2. X is going to be plus 1 by 2, right? It is going to be plus 1 by 2. Okay, please tell me if I am going very fast. Yeah, if I am going very fast, because this is a revision session. If you want to see it in the slow pace, please go back to the channel. In this channel, from chapter 1, I have taken, I think, some 9-10 sessions of this particular chapter. Okay, okay, so please go there. Okay, this is the revision session, so I am trying to do it as fast as I can. Right, just the important thing. Right, so now if I go back here, I can put it here. So t is equal to k, l to the power x. So l to the power x, x is plus 1 by 2. Sir, y is to the power 0, so m0, and g to the power minus 1 by 2. So what it will become? K root over. So l1 by 2, that is root g minus 1 by 2. It goes into the denominator. So it will become k root l by g. So we have no way to find the value of k, but later on, when you see, this k will come out to be 2 pi. This comes with the experimentation. And this experiment you must have done in your 11th physics also, na? Finding the acceleration due to gravity through this pendulum experiment. You must have measured the length of the pendulum, right? You must have used the stopwatch and all, right? So is it clear? Is it clear? Please answer me. What do you say? Is it clear or not? Okay, let's try one question. Yeah. So I'll give you the PYQ here. Just a minute. So where have you made the mistake, beta? I think if you realize your mistake wherever it is fine. See, you have to improve your efficiency. Now think you are learning the physics. Okay. So meanwhile you solve this question, I have one piece of advice for all of you. That is, see, if in the examination you attempted a question and in the end if it goes wrong, so that is going to harm you in a lot of ways. One, you have wasted your time. Second, you have attracted the negative marking. So if you are attempting a question, you must try to have it correctly. Okay. It is very important in the physics because the questions are time taking. Now please try this one. Let's see if we can do it or not. Sir, what is this coefficient of viscosity? Okay. I'll tell you. I'll give you the formula of coefficient of viscosity. So tau is equal to nu du by dy. So what is the tau? It is the shear stress. Okay, you are going to see it in fluid. Du is the change in velocity. Change in velocity. and dy is sort of a clearance, that is the difference of distance. Okay, clearance actually it is like the distance. Okay, please go for it. Let's see if we can do it or not. Please try it. Please try it. See, when you know the formula of something, I hope you can find the dimension to it also. Please try it. You have to get the value of x, y, and z. Similar question. Any answer, beta? Any answer? The live students, any answer, beta? May I do it? Let me do it now. So it says if dimension. Have you attempted it? I'll wait. I'll wait. No worry. I'll wait. Any answer? Okay, I think now the time I'll have to do it. So if dimension of critical velocity of liquid flowing through a tube are expressed as eta to the power x, rho to the power y, r to the power z. So what is there? So how we can write it? So how we can write it? So we can write eta to the power x. So that means the dimension of velocity. So velocity, critical velocity depends upon k times eta to the power x, rho to the power y, r to the power z. R to the power z, right? R to the power z. So how we can do it? So let's sort out the dimension. So we have to use the principle of dimension homogeneity. So it will be LT minus 1. K is a constant. We have to nothing to do with it. Now, what is the dimension of this eta? So eta is the shear stress. Okay. So what is the dimension of the shear stress, sir? It is M L minus 1 T minus 2, sir. How come? Because stress is there. No? So stress is force upon area. So force MLT minus 2 upon area, that is L square. So it will become ML minus 1 T minus 1. So this is dy. This is clearance. So clearance, that is dy. So it is going to be I, the difference of the distances or the heights. Okay. So this is going to be L only. And this du, it is going to be the change in velocity. Okay. So change in velocity will be having the unit of meter per second, that is LT minus 1. So from here, you can write the dimension of this thing. So it is going to be M L minus 1, see the dimension of eta, that is the coefficient of dynamic viscosity. So it is going to be M L minus 1 and T minus 1. Right? See this L minus 1, L minus 1 and L are gone. Then we have this L. So L goes to the, L goes to this top. So it will become L minus 1, and this T minus 2 upon T minus 1, it will become T minus 1. Now let's have the power x here. Okay, let's have the power x here. Now we have this rho. So rho is what? It is mass per unit volume. So M L minus 3. So this is going to have the power of y, and then this is r. So what is r? R is the radius of tube. So it is having the dimension of L. So L, it is going to be z. Now can we compare? So it is going to be 0 L1 T minus 1, and this is going to be M to the power x plus y, then L to the power minus x minus 3y plus z minus 3y plus z, and T to the power minus x, right? T to the power minus x. So what it is going to be x? So x is going to be, see, directly I can compare the power of the bases. So x is going to be 1. X is going to be 1. Do you agree? Yes, sir, absolutely. Now x is going to be 1. Now x plus y is 0. X plus y is 0. X is 1. So y is minus 1. Right, let's see if we are coming down to the right option. Yeah. So do we need to solve any further? So we got the right answer in the examination. Anyhow, you have to save the time. Are you getting my point? Now, what is the benefit of finding the value of z? Is there any benefit? Okay. Although if you want to find, you can put minus x minus 3y plus z is equal to 1. Now you can put the value of this xy. This is minus 1. This is going to be minus plus 3 plus z is equal to 1. So from here, you are going to get z is equal to minus 1. So again, you are going to get that. But don't do this in the examination. Okay. Now please tell me if this is clear too or not. Will you be able to deal with this kind of questions or not? Please answer me. Yeah. Please answer me. What do you say? Will you be able to deal with this kind of questions or not? So there is one variation to it. Okay. Yeah, this is how they ask you. One more question. So this comes into this type only. So this is the type 3, right? In zone 2, type 3. So this is the zone 2 question of this particular chapter. Okay. So in the zone 2 question, what is it? Okay. In this, they are asking you the things from the dimension analysis. In this, you can have 3 particular types. One in which you have to get the dimension of some values, okay, some variables. Another is that you have to check the correctness of the formula, and the third one is you have to develop the relation between physical quantities. Now you may try this one. Please try this one. Energy, velocity, time are chosen. So here they have changed the fundamental. What is the fundamental dimension are the 7 that we have seen? Okay, that's okay. Okay, but some physicist maybe he's trying to develop another, way of physics, and he has used the fundamental dimension of E, V, and T. Okay, then how the things are going to behave? Okay, this is one kind of question. that is getting asked in him. Please do it. Please do it. Please try solving it. I'm very, very sure we can do it. See, the same way you can do. Any live student who want to ask me something, you are most welcome. करिए कोशिश करिए. Please try to do it. Let's try to do it. See, there is nothing in this question that you can't do. Any answer? Any answer, beta? What is the answer? All these are NEET previous year questions. Shall I do it? Have you attempted? Now see, it is just they are confusing you with the language of the question. They say if energy, velocity, and time are chosen in the fundamental quantities, the dimensional formula of surface tension will be. So ultimately, what you have to do, you have to find the relation between E, V, T, and surface tension. That's all. That's all. So it is nothing but the question of the same level and the same way of approach as we were doing lastly. Okay. So here nothing you have to do. You have to write like this. Surface tension is proportional to sometimes surface tension is also shown like sigma. Okay. Just for your information. So this is going to proportional to e to the power x, v to the power y, t to the power z. Are you getting my point? Now, what is the dimension of S? It is mt minus 2. We just sorted it out now. Then what is the dimension of E? Sir, E is the M L2 T minus 2. How come? Think in your mind. Sir, energy Newton meter. Newton is MLT minus 2. That is why I told you to memorize the dimension of force, because you can use it in your mind to get the dimension of something. In examination, you have to be taking care of the time as well. So it is going to be ML2 T minus 2. Then this V, it is LT minus 1 to the power Y. Then this T is the dimension Z. So what we can do, we can write M L, okay, we haven't put x here now. So m to the power x, L to the power 2x. Okay, so let's write one way only. So this is going to be to the power x. So what we can write? We can write m to the power x. Now see, L to the power 2x, L to the power y. So can I write L to the power 2x plus y? Then we have t to the power minus 2x minus y plus j. Okay, the same way. The same way. Do you agree or not? Please answer me. The same way, isn't it? The same way. Yeah. Yeah. Okay. Now how we can do? We can equate the powers of the bases. So right away, x is equal to 1. Now let's see out that whether we are getting the right answer. X is equal to 1. So when x is equal to 1, x is equal to this can never be the answer. Okay. Okay. So you have sorted out like this. Now let's see, if x is equal to 1, then 2x plus y. 2x plus y, it is going to be minus 2. X we have, that is 2 and minus 2. So y, 2x plus y it is, na? 2x plus y. So 2x plus y, it is equal to, oh, this is t. Here I have written L. Sorry, my bad. My bad. T minus 2. So it is going to be equal to 0, right? Because L has no dimension here. Okay, this is mt minus 2, not L minus 2. I just have used. Okay, sorry. So 2x plus y, so y is going to be minus 2. Now let's see if we are coming down to the right option. No, sir. So we have to solve it completely. So y is equal to minus 2. So either it could be b or d. That is we are sure about. Now minus 2x minus y plus z is equal to minus 2. So we are getting minus 2, x is equal to 1. This is minus minus plus 2 plus z is equal to minus 2. So from here clearly z is equal to, from here clearly z is equal to, so I'll just write it here now because it is going behind my head. So this is minus 2. So minus 2 plus 2, it is going to be 0. So z is obviously minus 2. So it is going to be the B option, right? Okay. Now please tell me, will you be able to deal with these kind of a question? So there were, I have divided the questions, the probable question of the chapter into some zones. There was the zone 1 in which you could be asked about the dimension or units of some quantity. Okay. In zone 2, we have the application of the dimension analysis. Okay. Like you could have seen that checking the correctness of the formula, finding the dimension of any of the missing term, right? Then developing the relation between physical quantities. Is it clear up to this point? Shall we move to the zone 3 of the chapter? There are some limitation to dimension analysis that I have discussed very depth in the previous chapters. If you want, you can go to that and you can watch it. This is basically very exam oriented session, right? How the questions are getting asked and how we can approach it. So basically all the important parts are getting revised here. Please tell me if you have no doubt till this point. And afterwards we can move to the next zone. That is the zone of significant figure and errors. Two things are there. Significant figure and errors. And afterwards there is zone 4 in which we will be talking about the measuring instrument, that is vernier caliper and screw gauge. Okay, the chapter will be completed. So this is the one shot revision session. We are trying to cover each and everything in this particular session from this first chapter. No doubt, wonderful. So let's move to the next zone. So we are having this zone 3. Okay, we are having this zone 3. So in this zone 3, we need to see the concept of significant figures and errors. Okay, significant figures and errors. Okay, now, so I asked this question in the last session also. Let's see if you have watched that or not. So if I ask you something, okay, just to start with, is it equal to which option you would be choosing? What is the right option according to you? What is the right option according to you, Vita? The recorded students, those who may be watching the recording of this session lately, they may also think, they may pause the question, pause the video, they may answer this in their minds and then can further proceed with the. See, when students are watching recording these days, so they must watch. Again, my advice to you is you must watch as you are watching a live session, right? Most of the time. Very good, Vinika. So if you have answered this question correctly, many of the students would answer sir D, all of the above, right? So you have answered this correctly. So I think that you understand the concept of significant figure. But for the sake of revision, as you know, many other students are also be watching this video, so I'll be taking this liberty to explain this particular topic like briefly. Okay, sounds good. Okay, no problem. Na? Now, please observe. So, significant figure. Basically, so many students get confused here. That's the answer should be all of the above, but it is not like that. So, significant figure is something. What is the meaning of significant figure? So, significant figure is something that in any, so it is something, see, significant figure error, obviously, it is related with something in measurement. So, if you define a physical quantity, in physics, physical quantity is something which can be measured by an instrument. Now, when you are measuring something, there is always a possibility of error. Okay, and I can tell you with full responsibility that there is no instrument in this world for measuring any physical quantity with 100% accuracy. There will always be some error, no matter how hard you try. Okay, you how hard you try, how much money you put in, how much equipment you get, you cannot have the exact measurement anytime. Okay, okay, this is impossible, right? So basically, significant figure tells you in context to the measurement that in any measurement, or if you are writing the value of any quantity, to what amount of digits you are confirmed about. Okay, okay, are you getting my point? So basically, there is significant figure. Significant figure means that you have written 2.23. Okay. So if you have written this way, so significant figures tells you, like here, the significant figure is 3. How I'm telling you. So significant figure is 3. That means that you are sure that this is 2, this is 2, this is 3. Are you getting my point? You are quite sure about it. Okay. You have absolutely no doubt that this is 2, 2.2 and 3. So whenever you are sure about something, whenever you are sure about any digit in any particular value, you always call it a significant figure. So see, in significant figures, there are few things that we need to understand. First is the rules of significant figure. Second is the rounding off of significant figure. Rounding off. Third is the addition and subtraction. Okay, quite conceptual thing it is. Addition and subtraction, and the last one is multiplication and division. Okay, so if you have absolutely no idea, if you are watching this video and you have absolutely no idea about significant figure, I'll recommend you that sir, you go first and watch the chapter of significant figure. I have taught this on this channel. There I have exclusively dealt with the significant figure. Okay, okay, but like if you have some idea and you want to do it in a revision purpose quickly, then you stay here. Okay, so what are the rules? Because I'm not going to write anything. See, there are few rules. So first one is that all the non-zero digits are significant. Rule 1, non-zero digits are significant. Okay, significant figures. So whatever in any measurement, in any value, whatever non-zero digits you are observing, they all are significant. Secondly, trap zeros are significant. Trap zeros are significant. What are the trap zeros? The trap zeros are the zeros which are between the significant figures. Okay, there is two significant figure in any value, and there are some zeros in between those significant figures. Then they are called as the trap zeros, and trap zeros are always and always significant. Trap zeros are always and always significant, right? Then we have the trap zeros afterwards. Afterwards, we have, let's say, see, leading zero, third rule is leading zero or initial zeros are never significant, figures. Okay, initial zero, leading zeros, that is the zeros which are present at the very start of any value, they are never significant. Okay, fourth one is trailing zeros. Trailing means ending. Trailing zeros or ending zeros. Okay, ending zeros are significant figures if they appear if they appear after decimal. After decimal. So see, initial zeros are never significant, but ending zeros or the trailing zeros are significant, but they have to fulfill one condition, that they must be appearing after the decimal. Okay, so trailing zero, ending zeros are significant if they appear after the decimal. Okay, then we have see, order of magnitude is never significant. Order of magnitude is never significant figure. Like when we have 10 to the power 3, 10 to the power 4, 10 to the power 5, 10 to the power minus 2, minus 3, they are never significant. Okay. We have one more rule. I'll write it in the last. While conversion of unit, okay, when you are converting the unit, like we have converted kilometer to meter, meter to centimeter, minute, but any conversion of unit. So while conversion of unit, when you are converting the unit, so while conversion of unit, okay, significant figures must not change. Must not change. Okay. Okay. Like in this question. So 4.0 kilometers. So I have given the right answer as 4.0 in 10 to the power 3. So 4.0 kilometer, why it is not exactly equal to 4,000 meters? Because the significant figures are different. I'm going to tell you now. We are going to see some examples. Okay. So see, whenever you are converting the units also, you have to be careful that the significant figure do not change. The number of significant figures must not change. Now the one more rule is, so when there is a constant in formula, okay, formula has infinite significant figure. Infinite significant figure. See, like for example, if I say parameter is equal to 4 times of A let be the side of the square. Okay, okay, or refractive index of water is 1.33. So see, this 4 in this formula, or this 1.33 of water, refractive index of water is this. Huh? So if I say like this, so we are very sure about it. Now this is the part of the formula, or this constant has been evaluated experimentally and accepted by all of us. So these have infinite significant figures. Okay, so these are few rules of identifying or sorting out the significant figures. So let us give you some example. Okay. Okay. Give me significant figures in all. Give me the significant figures in all. Yeah, in the chat you can tell me. What is the significant figure? 1, 2, 3, 4, 5, 6, 7, 8. You can tell me the significant figures. You can identify the significant figures in each of these. Please go for it. Please go for it. I'm very sure we can do it. Please go for it. You just write in the sequence. No? You don't have to do 1, 2, or anything. As you wish. No worries. I'm getting that. The other live students can also respond to me. It's corrected till now. Vinika. Wonderful. Very nice. Very nice. What about the remaining of you, my dear? Wonderful. Okay, so I'll do it now. Now, please observe. So, we all have to apply just the rules. So, from rule 1, all the non zero digits are significant. So, it has all the non zero digits. So, it is having 4 significant figures. Now, in this, 2 and 1 are significant. So, these two zeros are trap zeros. This is what we call as the trap zero. That is the zeros which are lying in between two significant figures. So 2 is significant, 1 is significant because they are non-zero. Though in between two significant figures we have double zeros. So that is we are having these also a significant figure. So we have 4 significant figure again. Then we have 0.0020. So how many significant figures are there? Now, many students confuse that 0.00. It has to be significant now because 0 appears after the decimal. My dear, that is the ending 0. If ending 0 appears after the decimal, then it will be a significant figure. So, this is what we call as that. These are the leading zeros. These are the leading zeros. Okay, so leading zeros are never significant. So, 2 is a non zero. Okay, so it is significant, and this 0 is ending 0. This is your ending 0, right? So this is significant. So how many significant figures are there? 2 significant figures are there. Now in this 0.0, this is your leading 0. Leading 0 are never significant. Now this is 2. This is 002. So these 00 are the trap zeros. So we are having 4 significant. This is significant. This is. These 4 are significant. So we have 4 significant figure here. Now in this, how many significant figures there? So 5 significant figure. This 5 is what? 5 is non-zero, 1 is non-zero. All the non-zero digits are significant. Now between these two non-zero digits, that is between these two significant figures, we have trap zeros. So these trap zeros are significant. This 0 is the ending 0 and it appears after the decimal. So basically all are significant figure. So this is 3.212 into 10 to the power 3. So 10 to the power 3 is never significant. Okay, many students confuse into it. So this is never significant. So how many significant figures are there? So 4 significant because these 4 are non-zero digits. Then we have 110.201. So see, 1 1 is significant. These two zeros are trap zeros because they are between significant figure. So how many significant figures are there? So six significant figures are there. Now 0.10201. Okay, so this 0 point, so this is initial zero is never significant. Then 10201, both these zeros are trap zeros. So we have 10201. So basically these are two trap zeros, 121 are non-zero digits, so it is going to be equal to five significant figures. Okay, fine. Now one last. What are the significant figure in these two? What are the significant figure in these two? Can you tell me? What are the significant figure in these two? What are the significant figures in these two? Can you tell me that? Beta, there is only one significant figure into it now. See, this 2 is non-zero, so this is significant. And these three zeros are not significant. Why these are not significant, sir? They are ending zero, but the ending zero must appear after decimal also. Na? They must appear after decimal also. Na? So these three zero are not significant. There is only one significant figure here. Now in this, how many significant figures are there? Three significant, because 2 is significant and these two are ending zeros. These two are what? These two are ending zeros. So since these two are ending zeros, there is three significant figure to it. Is it clear, my dear? Please answer me. Now, in the same way, if we come down here in this question, so what is the rule? In the unit conversion, the significant figure, in the unit conversion, the significant figure must not change. Now, 4.0 kilometers. So, how many significant figure are there, sir? Two significant figure are there. So, two significant figures are there. Now, in this case, there is only one significant figure. So, this conversion is not correct in context to the significant figure. Now, in this, how many significant figures? Two significant figures are there. So, this is correct conversion. Okay, because in conversion, significant figure must not change. Now, see the third option. Sir, only one significant figure because initial zeros are never significant and the non-zero digits are significant. So, it is having only one significant figure. 10 to the power 4 is not significant. 10 to the power 4 is not significant. Okay. So this is not significant. This is not significant. So the answer is B. Now please tell me the rules of significant figures are clear or not. Please answer me. Can I mark a tick here? Yeah. The rules of significant figures are clear or not? Yeah. To everyone. Wonderful. Now let's talk about the rounding. Very important. Very, very important. So rounding off of significant figure. Rounding of significant figures. Okay, so how we can do the rounding of the significant figures? So please understand it. Please understand. It's very, very simple. Very, very simple. See, see. So we used to round off quite a lot. No, see. Let's round off to two decimal places. Let's round off to two significant figures. Okay, not two decimal places, but let's round off to two significant figures. Okay, so whatever I'm going to write here till the end of this rounding off point, I am not going to say it again and again because it is going to waste some time. We have to reduce it into two significant figures. Okay, so how we can do it? See, first of all, let's suppose we are having 4.67, we are having 4.56, we are having 3.26, we are having 3 or 5.18, 5.29 or something like this. Okay. So what is going to be the rounding off of it? Can you tell me? What is, so we want to see how many significant figures are there in these. So we are having three significant figures there in each of it. Now I want to reduce the significant figures to two significant figures. So basically I have to reduce one decimal place. I have to reduce one decimal place. So how we are going to do that? How we are going to do that? Can you tell me? Now please observe something. I'll tell you here. I'll tell you here. See, so you want to round this off. Okay, you want to round this off. Okay, this is something that you want to round off, right? Okay, because when you want to reduce one decimal place, you are rounding off this, right? So see, when you are rounding off any digit, you have just two choices. Either you can keep the digit as in the way it is, or you can raise it by 1. Okay, or you can raise it by unity. There is no third option. When you're rounding off, you cannot reduce it. You can keep it the same way, or you can raise it by 1. You cannot raise it directly to more than 1, right? So when we are rounding off, so see how I'm going to write it: 4.7, 4.6, 3.3, 5.2, 5.3. Sir, how you got to do this? In each of the cases, you have raised this digit by 1. 6 को 7 कर दिया. We did 7 from the 6. We did 6 from 5. We did 3 from 2. We did 2 from 1. We did 3 from 2. So why we have done it? Why we have done it? Because guys, the digit. So see, there is a digit that you need to round off. You have to check the digit next to it. Okay. Afterwards it. So when the digit afterwards it, that is I am referring to these ones. Okay. So these all digits are greater than 5. Okay. So simply when you want to round off any particular digit, so the digit next to it, if greater than 5, you raise it by 1. Again, I am repeating myself. Very simply, you are rounding off one digit. So whichever digit you intend to round off, you have to see the digit next to it. If that digit is greater than 5, you are going to round off that particular digit by 1. Okay. Okay. So that is why 6 becomes 7, 5 becomes 6, 2 becomes 3, 1 becomes 2, 2 becomes 3, because in each of these cases, these digits are greater than 5. Now, obviously, what is going to happen if less than 5? If less than 5, so there are only two options that you can do. Either you can keep, the digit the way it is. Either you can keep any digit the way it is, or you can raise it by 1. Okay, so if less than 5, keep as it is. Keep as it is. If the digit next to it is greater than 5, increase by 1. Increase by 1. Okay, very simple, isn't it? And we have been knowing this all along. No, if I say 5.13, 4.24, 1.31, 0.81 or 84, 0 point or 1.91, okay, or 1.76. Now, can you round these off for me? Can you do the rounding off of all these? Please go for it. Can you do the rounding off of all these? Please answer me. Please go for it. Can you please try this one? Please try rounding off them. Please try to round these off. Let's try. Okay, very good. So how we can do it? How we can do it? So 5.1 will remain 5.1. This is going to be 4.2. This is going to be 1.3. This is going to be zero point 0.8. This is going to be 1.9. Okay. Why, sir? Because this 3, 4, 1, 4, 1, all these are less than 5. All these are less than 5. So all these are less than 5. So the digit that you require to round off, so we want to change them to two significant figure. So when we want to change it to two significant figure, when we want to change it to two significant figure, okay, we need to round this 1 2 3 8 9. Okay, so in this case what is going to happen, it will remain the same because the digit next to this digit you need to round off is going to be less than 5. So when it is less than 10, you have to keep it that way only. In the last case it will become 1.8. So I have made this question here because in the flow you don't make that mistake, right? Okay. Okay, so this is going to become 1.8. I hope it is fine to everyone. Yes. Okay. Now the question that must come in your mind, that okay, when it is greater than 5 we raise some digit, when it is less than 5 we keep it that way. Now what happened when it will be exactly 5? Now if it is 5.15 exactly, okay, so you want to round off to two significant figures. So the question is you need to round this off. Okay. Okay. So now what if the is digit after this is 5, exactly 5. So when it is exactly 5, what to do? When the digit after the digit you have to round off is exactly 5, then what we need to do here? Okay, now there can be three possible cases. Okay, there can be three possible cases. If the digit after the digit that is to be rounded off is exactly 5, there can be three possible cases for that matter. Now please understand this. So it could be written, so case 1 I'll be talking about. So there are three cases. One is case 1. So I'll write on the next page so that we can have it here, all the cases. So case 1, when see, when it is not, no, please have this clarity in your mind. If it is greater than or less than 5, there is no point of confusion. The point of confusion is only when this is exactly 5. The point of confusion is only when it is exactly 5. So what is the case 1 here? So what is the case 1? It is, let's suppose we have 5.151, we have 6.252, we have, I'm just randomly writing some numbers, okay, 1.353, we have 0.454, we have 0.555, okay, sir, we have 5.156, we have 6.257, we have 7.358, we have 8 point or 2 point, anything, just randomly I'm writing 159. Okay, now I want to round them off. So what is the case 1? This will come into domination dominance when only the digit next to the digit you require to round off is exactly 5. Now please understand this. So now the digit after exactly 5. So this is exactly 5. You see the next digit to it. You see the next digit to it. So when you see the next digit to it, so it is a non-zero number. So if digit after 5, if digit after 5 is non-zero, if digit after 5 is non-zero, if digit after 5 is non-zero, okay, if digit after 5 is non-zero, round off by raising 1. Okay, so just you have to see whether the digit after 5 is non-zero or zero. Okay, not zero. Okay, again I'm repeating myself. I'm actually correcting myself over here. So if the digit 5, if there is exactly 5, not greater than 5, not less than 5, you need to round off. So for that, you have to see the digit after the 5. So if the digit after 5 is non-zero, if digit after 5 is non-zero, you need to round off by raising 1. You just have to see whether it is 0 or non-zero. Okay, if it is non-zero, you can raise by 1. So it will become 5.2. Okay, because we want to reduce to two significant figures there. So two significant figures, this is exactly 5. You check the next digit. If it is non-zero, you don't have to see. Anything else, you can raise the digit by 1. So this will become 6.3. This will become 1.4. This will become 0.5. This is going to become 0.6. So I'm not checking whether the digit next to it is greater than 5, less than 5. We are just seeing if it is non-zero or not. That's it. This is going to be 5.2. This is going to be 6.3. This is going to be 7.4. This is going to be 2.2. Please tell me if it is fine to everyone or not. Please answer me. Yes or no? What do you say? What do you say? Please answer me. Please answer me. Yeah? Okay. Is that clear? What to do when the digit is exactly 5? It is neither greater than nor less than 5. So what is to be done? You have to check if the next digit to 5 is non-zero. What you can do, you can raise it by 1 if non-zero. Now sir, what could be the case 2? Now what could be the case 2? Wonderful beta. What could be the case 2? So the case 2 can be that it is 1.150 or it is 5.250. Okay, so the digit is 0, then what to do? Okay, so sir, see, please see the sequence. You want to round off to two significant figures. Okay, now for that you come up, you see, okay, 5.15. So it is 5, neither greater than 5 nor less than 5. So now what to do with 1? Okay, so it is exactly 5. Now you check the next digit. Next digit, if at all it is non-zero, you know what to do. But now when you check the digit after 5, it is 0. Now the question is what to do. Now the question is what to do. Now here in this case, please observe. See, here you have only one option. Now you have moved forward, but you find nothing. Now you have to move backward. Okay? जब आप आगे देख रहे थे तो कुछ नहीं मिला, ठीक है? अब आपको पीछे देखना पड़ेगा. तो 5 से पीछे देखेंगे. We are going to see backwards to 5. So when we are going to see backwards to 5, this is an odd number. So if the digit behind 5, okay, if the digit behind 5 is an odd number, you can increase it. And if the digit behind 5 is even number, you can keep it the same. Are you getting my point? So what happens? What happens if the digit after 5 is 0? You have two cases. So case 2 has two segments. These are having two possibilities. So if digit behind 5 is odd, if digit behind 5 is odd, raised by 1. If digit behind 5 is odd, raised by 1. If digit behind 5, okay, if digit behind 5 is even, Keep it that way. Keep it that way. As simple as that. Okay? As simple as that. So I hope you have understood how to round off. Yeah? What do you say? I hope you have understood how to round off. Please answer me, yes or no? Yeah. Had some water. Yeah? Wonderful. So can I mark? So we can do many cases. No? 1.250, 1.368, okay, 5.550, 0.691, okay. And in all these cases, you have to round off to two significant figures: 0.651, 0.7.985. So can you please round them off? Just like for sake of implementing the concept we have learned. Please go for it. Each you have to round off to two significant figures. Okay. All we have to round off to two significant figures. Knowing the concept, you can round off to any numbers lately, as and when required. Please try it. Please try it. Wonderful, Vita, wonderful. So you have done the rounding off correctly to each of them. So sir, this is 250. Okay, so sir, it is exactly 5. So exactly 5, the next term is non-zero. So we have to go behind, sir, 2. It is an even number, so you will keep it that way. 1.368, so this is greater than 5. So this is greater than 5. So obviously we are going to raise the 3 by 1. So this is 5.550. So this is 5. Okay, after digit is not 0. Now we have to see behind. So this is odd. So if it is odd, we have to raise by 1. Now 0.691, 9 is greater than 5, no scope of confusion. So we have to raise this 6. Now 0.651, sir, 1 is non-zero. After 5 it is non-zero. Non-zero after 5 it is. So we have to raise it. Okay, why we have to raise it? So this is even. This even odd thing work if the digit after 5 is 0. See, you have to be very clear in your mind. Are you getting my point? So this is 7.850. So it will become 7.8. Why? Because after 5, this is 0 and this is even quantity. So I hope rounding off is done. So can I mark a tick here? Right? Where we were? Rules are done. Rounding off is done. So addition and subtraction. Now let's come to this addition and subtraction. Now, rules of addition and subtraction, very, very simple. Very, very simple. Okay, addition and subtraction. And I'll write the rules for multiplication and division here itself so that you never have the confusion between the same. Okay, I'll write rules of multiplication and division. I'll write the rules of multiplication and division. Okay, rules of multiplication and division. So rules of addition and subtraction. So please understand this. So see, whenever you are adding or subtracting or multiplying or dividing the significant figure, the first thing you have to do normal. The first step is to do the normal addition, subtraction, the normal addition, normal multiplication and division. So the first thing is do addition and subtraction normally. Now in the same way, here also do multiplication and division or division normally. Okay, so I'll just write do normally. So the first thing you have to do it normally. So how we do it normally? The same way we learned to do when we were in छोटो छोटो बच्चा, जब हम लोग छोटा बच्चा था तब जो सीखा था वही करने का. Are you getting my point? When we were small kids, we have learned to do this, isn't it? है ना? Right? So the same way we have to do. The same way we have to do. That is what I mean by doing it normally. So we have to add, subtract, multiply, divide. First of all, normally. Now the second point is very important. So the result of addition and subtraction, the result must be rounded off to same number of. So I'll just change the color of the pen. I'll just use the red. Okay, red means danger. So the result must be rounded off to same decimal places as present in the value with least decimal places, as present in the value with least decimal places. Okay, so basically you are adding some quantities, maybe 2, maybe 3, maybe 4. Okay, so when you are adding some quantities, the value which is having the least decimal place, okay, the final result must be rounded off to the same decimal place. Are you getting my point? So here, important thing is that when you are doing addition and subtraction, you are rounding off the solution to the same number of decimal places, not significant figure. Mind you, not significant figure, but the decimal places. Okay, with time, this confusion comes to us that, sir, are we rounding off to the lesser number of significant figures? No. We are rounding off to the same number of decimal places as present in the value with least decimal places. So here, decimal places is something we are looking at. Okay. Now, what is the rule of multiplication? Now, in this, what we have to do? So the result must be, okay, the result must be rounded off to, I'll just write least significant figure. Least significant figure. Okay, so what I mean, least significant figure. Okay, so what I mean here, that if there are two values, so same thing. Okay, because the space is less, I want to keep it on the same page. I am just rounding off what I am writing. Okay, so the result must be, so it must be like this, the result must be rounded off to the same number of significant figures as present in the value with least significant figure. Okay, rounded off to same significant figures. Okay, I'll just try to fit it. The result must be rounded off to same significant figures as present in value with least significant figure. Now you can keep it your way, okay, because there is no space. So the point is that when you are adding, the major difference or the key difference or the key point or the thrust area is that when you are adding and subtracting two significant figure, you must keep the same decimal place in the solution. You must round off to the same decimal place in the solution, okay, in the solution as present in the value with least decimal place. Okay, and rules of multiplication and division are that you must round off to same significant figure as present in the value with the least significant figure. I hope it is fine to everyone. Right? Now let's take one or two examples so that we sort it out. So let's suppose we are having just a simple example 3.39 plus 0.4. Okay. Okay. Now please add them. Please add them. 4.212 minus 0.31. Okay. Please go for it. Please go for it. I'm very sure we can do it. Then we can have 2 there multiplied also. Na? So I have to make some calculations. So better to see with this. So 0.9 divided by 4.26. Right? Please solve this cases. Please solve these ones. So those who want to do more questions, so many questions I have taught, we have done in the session of significant figures. That video is available on the channel. You can go and watch that video. Right? What is the answer to the first one, beta? Please try to do that, beta. Very good. So how we can do it, my dear? How we can do it? So the first case, the 3.39. So first add them. First add them normally. So 3.39, 0.4. बच्चों की तरीके से करते हैं तो for 3 plus 4 ये हो गया 7 और ये हो गया 3.79. So is it the right answer? No, sir. When we are adding down, when we are adding something, we have to reduce. When we are adding two significant figures, we have to round off the solution. We have to round off the solution to the same number of decimal places as present in the value with least decimal place. So here two values are there, 3.39 and 0.4. So we have to reduce the answer to one decimal place, so 3.79. So this will become 3.8. No, you have made the mistake, beta. Right? Your answer would go wrong, Vinika. Are you getting my point? This will become 3.8. Right? Why, sir? Because 3.79. See, that is what is there. You need to round off. So you must be aware of the rules first. Did you get my point? So you, I think, have forgotten to round off. So this will only come when you practice. Okay? When you practice. Right? Okay? So this is going to become 3.8. Now, when we are subtracting 4.212 with 0.310, so this will become 2. This is 0. We'll take the carry forward here, and this will become 9, and this has become 3. So 3.902. Are you getting my point? Now, is this the right answer? No, sir. Is this the right answer? No, sir. Why? Because when in addition, when we are adding and subtracting two significant figures, the final result must be rounded off to the same number of decimal places as present in the value with the least decimal place. So 4.212, that is 0 minus 0.31, that is 3.902. So here I have to round off this result into two decimal places. So it will become 3.90, right? right? Now 2.1, 2.1. So it is multiplication. So we are multiplying it to 4.41. Okay, 4.41. So how many? Now in this case, what we have to do? 2.1, 2.1 is equal to 4.41. Agreed? Now, is it the answer? Now, is it the answer? No, sir. This is not the answer. Why this is not the answer? Because when we are multiplying two significant figures, the result must be reduced to the same number of significant figure as present in the least value of significant figures. Okay. Okay. So these two have two significant figures. So final answer shall be rounded off to two significant figures. So this will become 4.4, right? Now what it is going to be? What it is going to be? So sir, when we divide it, we are getting, so if we divide 0.90 with 4.26, so I have already divided it. Okay, so it is 0.21126. So, okay, you can see it. It is 0.21126. Now, is it the solution? No, sir, this is not the solution. Why? Because see, in multiplication and division, we want to reduce it. We want to round off the solution to the same number of significant figures as present in the value with least significant figure. Okay. So we want to reduce it to two significant figures. So it will be becoming 0.21. It will be becoming 0.21. Now, can I mark a tick here and here also? Okay. Will you be able to deal with the significant figure? Yes or no? Please give me a yes. Then we'll move to the errors part. Okay. Errors part. Please go for it. Please tell me. Please tell me. See, if you want to know, if you want to solve more question, if you want to have even better understanding, so please go to the main session and watch it of significant figures. I have completed it very comprehensively in very detailed manner. Here in one session, I am trying to complete the whole unison measurement. Okay. So if we enter into depth of each and everything, so I am giving you the each and every concept. Now, no concept I am missing here. Okay. Okay. But still, I'll recommend that if you haven't watched the previous sessions or if you have no idea, please don't watch this session. First, watch them, then use this session as a purpose of revision. Okay. Now, moving ahead. So, significant figures is sorted. Significant figures are sorted. So significant figures are sorted. Now let's move to the errors. Okay, errors. The next part to it. Now in the errors, there is two things. One is finding the true value, finding the true value, or we call it mean value, or we call it actual value. All are the same thing only. Okay, all are the same thing. Okay, and the second part is finding mean absolute error. Okay, this is the first phase of this. Then basically we have to move to the part of propagation of error. Propagation of error, that means what happens when the quantities having errors are added, what happens when they are subtracted, and again, like the significant figures, addition subtraction holds the same rule and multiplication division hold the same rule. Okay, multiplication division holds the same rule. Okay, now please understand. Please understand this. The second part of propagation is very, very important. Most of the questions are getting asked from the part of propagation, but we have to see the first part also. We have to have it in the same way. Now, please understand this. Now, please understand this. So, just before some time, I said something that no matter how hard we try, we can never get the exact value of something. Now, the question is that if you are saying that no matter how hard we are going to try, we cannot get the exact value of something. Now, in that case, how we are going to get the true value of something? And unless we have, guys, the exact value of something, how we are going to get the error? How we are going to get the error. Are you getting my point? How we are going to get the error? So guys, now for that, what we can do? Now for that, what we can do? This is something we are basically interested upon. Okay. Okay. Now please understand it. Let me tell you. Okay. Let me tell you. Please understand it. So if you want to measure, you want to get the true value of some quantities, actual value of something. Let's suppose that thing is x. Okay. X can be anything. Okay, it can be anything. So for that, what you can do, you cannot get the true value. So how you can approach nearest to the true value? So you can take multiple measurements. Okay, let's suppose that you have measured it multiple times, x3, xn. So now what is going to be the mean value? What is going to be the mean value? So x we call the mean value here. You can write xm also if you want. So all you have to do, you have to take the average of it. You have to take the average of it. So this is going to be x1 plus x2 plus x3 plus xn upon n. So you know how to take the average, right? That is not a problem, sir. We very well know to take the average. So when you want to get the true value, actual value of something, you have to take the average of all the measurements if given, right? Okay, this is the first thing. Now the second thing is, sir, will there be any error in this true value when you are calling it true value? So is it there any error in this true value? Yes, absolutely there is error. Okay, no quantity can be without any error, right? Because there are errors in each of the measurement. When you are taking the average also, there is some possibility of the error. So what is going to be the error in this whole quantity? For that is what we call as the mean absolute error. So this is how we calculate it. So we can calculate it by taking average of all measurements. Okay, जितना भी measurements है उसका average लीजिए. All the measurements का आपने average ले लिया. So you get the mean value, actual value. Now, how we are going to get the absolute error? So इसको हमने x करा. So there is some mean absolute error to this x also. So let's call it delta x. Let's call it delta x. So what is the absolute error? So absolute error is the error that happens to be in each of the measurement. Okay. So you have the actual value or the mean value. So from the actual value, mean value, you can calculate the error in each of the measurement. You can calculate, let's suppose we have done n number of measurements, and n number of measurement, in n number of measurements we can have the error in each of the measurements. So delta x1 is x minus x1, delta x2 is x minus x2. Then we have delta x3 is equal to x minus x3. We have, similarly, we can have delta xn as x minus xn. So what you can do, you can find the error in each of the measurement. You can find the error in each of the measurement. So when you are finding the error in each of the measurement, what you can do, you can get the mean absolute error. This is your mean absolute error by taking the average of all these errors. So when you take the average of all these errors with mod sign, okay, we are just interested in the magnitude. Some errors may be in positive, some errors may be in negative. We have nothing to do with them. Okay, we are just interested in their magnitude. So that is why I have written mod here. So delta x1 plus delta x2 plus delta x3 plus delta x4 and so on, divided by whatever number of quantities you have used. Okay, okay, so you have the delta x of something. You have the delta x of something. So this is your mean absolute error. And what is the right way to represent some quantity? What is the right way to represent? What is the right way of representing some quantity? Right way of representing some physical quantity is this. Please understand it. So let's suppose you are representing some length. So it is 10 plus minus 0.1 ml. Okay. This is the right way. Okay. So when you are representing some quantity, some physical quantity, it may be length, it may be time. Okay. 5 plus minus 0.5 of second. Okay. Okay. Right. Okay, so when you are representing some quantity like this, basically what happens? This 10 or 5, this is what we call as this is your mean value or the true value we are referring to. Okay, the mean value or true value we are referring to, which we have calculated by taking the average. So most of the time, although you must know how to get the true value, but in questions, most of the time, what is there, we are given the data like this only. Okay, 10, 5. Okay, and this is what, this is your delta x. This is your delta x. Okay, this is your delta x. I hope it is clear to everyone, right? Delta x is what? That is your mean absolute error. So any quantity, any physical quantity, the right way of representing the physical quantity is with its true value and with its error. This is how the things are represented. This is how a physical quantity should be represented. And in the questions mostly they are presented in this way, right? Is that clear, my dear? Please answer me. Okay, what is true value, what is absolute error, mean absolute error? Okay, so you may be asked to calculate that also. The live student, please answer me, beta. I just want to show you something, one question, so that you get the idea that what we are going to do here, right? This is the quick way of revising, right? Sometimes we'll be using the questions even to revise. Yeah, just one moment. I want to show you one question so that you get the idea from it. Yeah, it's okay. Okay, so you got my point. No worries. So let's move further. Now please understand it. Now we are going to talk about one very important part, that is propagation of error. That is propagation of error. Okay. Now what is this propagation of error? So what is going to happen to the error in, again, addition and subtraction? Again, addition and subtraction. Okay, and multiplication and division. Okay, multiplication and division. So what is going to happen to the addition when the, so see, there are two quantities. Please understand this. There are two quantities. Okay, so let's suppose we have two lengths. Okay, so this is the screw gauge I am having. Just this screw gauge and this pen. So this must be having some length, this pen must be having some length, and I keep them point to point. Okay, now each of the length of these things will have some error. Okay, so we may require to interact between the physical quantity, different physical quantities, which individually having some of the error. Okay, so when we require to add or subtract two physical quantities, simply I'll tell you in one line, errors are added. Okay, whether it is addition, whether it is subtraction, you have to just add the error. Are you getting my point? You just have to do one thing, you just have to add these errors. Okay, so how we do it? Let's suppose we have L1, that is 3.0 plus minus 0.2 mm. Okay, and we have L2, that is 5.0. Okay, and this is plus minus 0.1 mm. Okay, now you want to add these two. So first add their true value. Okay, first add their true values. So what are the true values there? What are the actual values there? So the actual values are 3 and 5, that is 8. Okay, 8.0, and see whether it is, what is the rule, whether it is addition, whether it is subtraction. In both addition and subtraction, errors are always added. No matter whether it is addition or subtraction, errors are always added. So this will become plus minus 0.3 mm, right? plus minus 0.3 mm. Similarly, if you want to do L2 minus L1, then what is going to happen? So, sir, you first subtract the true value, that is 5 minus 3, that is 2.0. And again, in this case, also the errors are added. So, don't subtract the errors in the case of subtraction. Okay. So, why is it like that? So, please watch. See, this is the revision session. I'm just telling you, so I can explain this why. But I recommend that if you want to know that why it happens, you go back to other video. Okay, on this channel I have given you some more videos as well, so that in those videos of errors you are going to see the propagation of error video, you are going to get it. Okay, so this thing is clear, it seems. So can I mark a tick here? Okay, good to go. So now moving to addition, multiplication and division. Very, very simple. Please observe multiplication and division. Okay, multiplication and division. So now in the case of multiplication and division, see, there is, let's suppose x is a into b. So many students say, sir, it will very simple, when delta a plus delta b it will become, or delta a into delta b it will become. No, don't do like that. Don't do like this also. Delta a plus delta b, don't do like this also. So this is not the way. You have to use a bit of differentiation concept. So if x is equal to, see, if x is equal to a into b, or x is equal to a by b, okay, a by b, all you have to do, this comes up from the principle of differentiation. You need not to do how it comes. Okay, for NEET, not much mathematics is required. So what amount of mathematics is required, I'm going to tell you in the next chapter. Kinematics I'll be starting, and in that, whatever amount of differentiation and integration you need, we are going to do it there. Don't worry. So it is going to become delta x by x is equal to delta a by a plus delta b by b. Are you getting my point? Delta a by a plus delta b by b. Right? Okay. In both the cases. Not only in multiplication and not only in division. In both the cases, the result is going to be the same. So you can have the link of this in your mind also, like significant figures also, the same thing was happening. In addition, subtraction, the rule was the same. In division, multiplication, the rule are the same. Now, same way, here also, when you are trying to see that what happens, how errors propagate during addition, subtraction, multiplication, division, so you can remember that in addition, subtraction, the rules of errors are the same. The rules of errors are the same. And in multiplication, division, the rules of propagation of errors are the same. Right? So what if one more quantity C we multiply here? Okay. What is one more quantity D we divide here? So what happens then? What happens then? So I'll just do like this. C, I'll write it here. So in that case also it will become delta C by C. No problem at all. What is the problem? Right? Okay. No problem, sir. No problem. Now, sir. What if, sir, if it is written like this? What if A, let's suppose 1 by x is equal to 1 by A plus 1 by B? Okay. 1 by A plus 1 by B. Then how we are going to do it? How we are going to do it? Okay. So, sir, we can do it. Sir. We can use our some of the brains, and we can use our common sense to do it. Sir, how we are going to do it? So 1 by x will become AB, and this is going to become A plus B, right? So x is equal to AB upon A plus B, right? So delta x by x. See, using the same concept, delta x by x will be delta A by A plus delta B by B. Then whole of this denominator, delta A plus B. So here in this case, you are going to use this A plus B as one entity. Are you getting my point? So A will be, there is A plus minus delta A. There will be B plus minus delta B. Okay. Okay. So simply what is going to happen? You have this delta A, you have this A. So A, B, these are the true values. Delta A, delta B are the errors, mean absolute errors to these values. So how you are going to deal with in this case also, I think it is clear to you. Yes or no, please answer me. Okay. Okay. Right? Will you be able to deal? Just you have to put the value. So can I say multiplication and division is also done? Now one more thing is there. one more thing is there. So when there are some quantities, when there are quantities which are raised to some power, the quantities which are raised to some power, okay, raised to some power. So in this case, what you need to do when quantities are raised to some powers, when quantities, see, very simple it is, quantities raised to some powers, okay, raised to some powers. So in this case, let's suppose x is equal to a, B, C. So let's suppose this is P, Q, R. Whatever you want, you can do. So this is going to be delta x by x is equal to P delta A by AC. Very simple. Plus Q. So you are multiplying the power delta B by B plus R delta C by C. Is that clear, my dear? Very simple. No? All the powers you are just multiplying to the same thing, right? Simple. Yes or no? Now please tell me if it is clear or not. So we can mark a tick here. Now we'll do some questions, right? Please tell me if we have any doubt till this point. Please tell me if we have any doubt till this point. Can you please tell me? Yeah. And also you can like see when you write, so this delta x by x when you write, so this is also known as the fractional error. Okay, this is what we call as the fractional error. So whenever you have the absolute error to that quantity, this is also known as fractional error. So if they ask you the fractional error in the question, right away you can do like this. And if you multiply it by 100, this will become percentage error. Okay, so sometimes they ask you to find the percentage error. So in that case, what you are going to do? In that case, what you are going to do? You are just going to multiply 100 to this all equation. All will become the percentage error. So if I multiply 100 to this equation, how can I write it? Percentage error in x is equal to p times percentage. And this is the formula how they write in the books now. In A, okay, because when I multiply it with 100 plus Q times percentage error in B, right, plus R times percentage error in C, right? Can we write like this? So let's solve one question, my dear. Oh, this one is already solved. Huh? I'll just come up with one question. Let's solve one. Let's solve this one. Please try it. So this is x. I'm writing it here because this is typed format b1 to the power 2 upon c1 power 3 d to the power 3. Okay. Okay. Please go for it. Please go for it. Please try it. I'm quite sure you can do it. Please go for it. All the live students. So we will be solving only one question of error here. Sir, I have taken error session in two phases in YouTube. Okay. On this channel, if you see the videos, right, you are going to see the videos on errors by the name error analysis and by the name questions on error analysis. So there you can go, you can see many more questions, and I recommend there is one question I have solved. Time period. Okay, time period of pendulum, error in calculation of acceleration due to gravity through the setup of pendulum that we do in the 11th class. So that question I'm not going to give you in this session, okay? Because now I want to, because it is almost 3 hours we have been revising this particular chapter, okay? Very good, Vinika. So now for those questions, if you want to do, you can go back to the video of error and its analysis. You can forward the question. If you understood all the concept, you can forward and go directly to the question. So you can use the technology, right? Now please observe. So see how very simply we can do. So it is given that x is equal to a square b1 to the power 1 to the power 2, sorry, b to the power 1 by 2, c to the power 1 by 3, d to the power 3. So from here, what we can do, we can use the principle. So delta x by x is 2 times delta a by a, okay, plus 1 by 2 times delta b by b, plus 1 by 3 times delta c by c, plus 3 times delta d by d. So with practice, you won't even have to write anything, right? Okay, right away you can do. Like if I have to do this question, I can do this in 40 seconds. Okay, I'll do it in my mind. 2 into 1 plus 1 by 2 into 2 plus 1 by 3 into 3 plus 3 into 4. So you have to increase your speed also. Okay. So basically now if I want to do it in percent, I have percentages given. So like percentages, percentage, 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 percentage. Now what is going to happen? 2 into 1, so it will become 2. 2 into 1 by 2 will become 1, plus 3 upon 1 by 3, it is 1, plus 3 into 4, that is 12. So it has become 16%. Will you be able to deal with this type of question? Please answer me yes or no. Right? Please answer me. Yeah. What do you say? Errors is done. Can we have a thumbs up here? Yes or no? Now one last concept that is remaining here is about the measuring instrument, right? Vernier caliper and screw gauge. Okay. So very comprehensively, I have taught vernier caliper. There is a 2-hour video, I guess, I assume. And screw gauge also, I have taught in somewhat 1 hour 30 minutes. Okay. Obviously, I'm not going to give you that much in this session. Within 10-15 minutes, I'm going to give you the basic formulas and we are going to close this session. Because see, when we talk about the experimental things, okay, like the vernier caliper, screw gauge, see, it is, you have to give time to it. There is no other option. It is something very practical now. Okay, like vernier caliper, if I try to teach you here perfectly, it is like I am trying to tell you how to drive online. I am telling you, okay, this, take this accelerator, okay, or how to manage the handle, right? So this is something which has to be done experimentally. So I'll give you just the formulas and I'll let this session be completed. So see, there are two things. Vernier caliper, okay. See, if you want to have very clarity in this, I would recommend please watch the video of screw gauge and vernier caliper present at this channel. I have taken it very comprehensively. Okay. So just I'm going to tell you a few things. So the least count of vernier caliper is main scale division minus vernier scale division. One important point. Okay. You will be requiring the least count in all the cases. Okay. Least count in all the cases. Okay. So main scale division and the vernier scale division. Okay. So when we see this vernier caliper, there are two scales. One is main scale and one is vernier scale. Right? Okay. One is the main scale and one is the vernier scale. Okay. Okay. So if we have one, so I hope you have seen. Okay. So I don't exaggerate it, right? Because see, if you want to understand this completely, you have to watch the other video. Okay. Because it is impossible to teach these kinds of topic. According to me, I can tell you the formula. Okay. So for revision, that is why I have said that this is the complete revision session. Okay. So don't mind me saying that. So least count is MSD minus VSD. Now remember, in general, n divisions of vernier scales are equal to m divisions of the main scale. So one vernier scale division is m by n of the main scale division. So the least count is least count is MSD into 1 minus M by N, right? Okay, so these two formulas are predominantly used. Okay, now the second thing in this is the total reading. The total reading or the reading of 1 year caliper, so we call it total reading. Okay, so this is the main scale reading plus 1 year scale reading. Okay, okay, so what is the main scale reading and 1 year scale reading? I'll tell you. Okay, before that, I'll tell you the screw gauge thing also, because see, there is very similarities in these two. Are you getting my point? There is lot of similarities in these two. Okay, so in this case, what is the least count? Least count is the pitch. Okay, okay, so what is the pitch? How to see the pitch? You have to see, you have to go. I'm again telling you, this is not sufficient to understand these topics. I'm just giving you a quick revision to it. So screw gauge, the least count is pitch into upon number of divisions on circular scale. So like the 1 year caliper which has a 1 year scale, the screw gauge have a circular scale. So the circular scale is having some division. Okay, this is the, see in that session I haven't shown you the screw gauge. This is the screw gauge. Are you getting my point? So this is the circular gauge. There is some reading, there is some divisions on this circular scale, there is a main scale. So both of them have a main scale. Okay, 1 year caliper have a 1 year scale, screw gauge have a circular scale. Are you getting my point? So the least count is the pitch upon number of divisions on the circular scale. Okay. Now, second thing, what is the total reading? What is the total reading? So here, the total reading is going to be main scale reading plus circular scale reading. Main scale reading plus circular scale. So quite similar to each other, right? Now, what is the main scale reading? Okay, what is the main scale reading in both the cases? So it is the reading. It is the reading on main scale just before zero, just before zero of secondary scale. Now, what I mean by the secondary scale? What I mean by the secondary scale? So the secondary scale in the case of 1 year caliper is what I mean from the 1 year scale, and the secondary scale in the case of screw gauge is what I mean from the circular scale. So the main scale reading is same in both of it. It is the reading of the main scale just before zero of the secondary scale. I hope it is fine to everyone. Yeah. Okay. Same thing in both the cases. Now, what is VSR and what is CSR? That is the circular scale reading. So they are also the same. So I'll write the secondary scale reading. That is, I refer to the main scale reading or the 1 year scale reading. Sorry, the 1 year scale reading or the circular scale reading. So secondary scale reading is nothing but the least count into coinciding division of secondary scale, coinciding division of secondary scale. Okay, in both the cases. So see, the very simple questions that you will see from this particular topic, you are going to get these things. Are you getting my point? So in the both the cases, like for example, when you see the 1 year caliper session, you are going to see that 1 year scale reading is least count into the coinciding division of 1 year scale with the main scale. When you see the session of screw gauge, you will come to know that the circular scale reading is least count into coinciding division of circular scale with the baseline of the main scale. Are you getting my point? Okay, so both are the same thing. Both are the same thing. Now, there is one more concept of zero error, but that is not very much asked, so I'm not covering it into this session. So for that, you can see again the session of 1 year caliper and the screw gauge, right? Okay. So I think that in this session, I have given you a complete revision. I have covered all the topics that we have learned in all these sessions of units and measurement. Okay. Okay. So if you have watched it, I hope this session has given you a quick revision. Okay. Within, I think this is the very big chapter, and I think I can see that 3 hours, 10 minutes it is. So nearly in 3 hours 10 minutes we have got a complete revision of this session, right? Okay, so shall we end the session? Okay, so one last thing for this session. Any doubt before I leave the session? Any doubt in this session? Yeah. Did you enjoy the session or not? Any doubt, beta? Just one second. Huh? I cannot. See, my dear. I'll definitely try. Okay, I'll definitely try. I'll try to be more quick. Okay, but the thing is, see, we have some implications too, right? So actually, on the you know app also we have to take the classes. So many things are there. So we have targeted it till March. I'll try to complete it till Feb. Okay, but you see, like it's a tough examination. I'll try from my end as much as possible. Sounds good? Yeah. But what I feel that November, December, January, February, so 4 months are there. So in that way, see, I have to skip a few things. I'm trying to cover as much as possible. Okay. And if at all I'll be skipping something, I'll tell you. See, I'll try to complete in by the mid of March. Okay, and you see, if I skip something, I'll tell you. Sounds good. Okay, that this is something that you may learn by yourself. If some easy topic is there, or the topic which require less attention, will that work? Yeah. Okay. Yeah, Vinika. See, see. I can tell you one thing. Okay. See, every teacher more or less is doing the same thing. Like I am also a teacher. I can only teach you, right? There are n number of ways to check that whatever I have taught is for NEET, it is good enough or not, right? But this is a competitive examination. See, I can lie to you. Like I can say, sir, whatever I teach you, there is nothing is going to be out from what I teach. But this is a very wrong statement to make. See, I have seen many people are making such a statement. I am not into that. What thing I can tell you that you can check my content from anywhere you want. Okay, no one is teaching more than what I will. That I can say. Okay, but whatever I am teaching from there only the questions will come. This is a wrong statement to me. Are you getting what I am trying to say? Right? Okay. So some effort you have to do, some effort we have to do, and definitely it will be going to have. Okay. So the students who are studying, like some seniors of you who are getting the good medical college, how they get the college? It, there is only one thing they have done. They have studied. They have revised properly. They have done the questions. Okay. They have managed their time properly, and they were serious. There is no other requirement. If you are having all this, okay, definitely you are going to get through. Right? You don't have to seek from me or for anyone that whether you are going to get in or not. Are you getting my point? Right? Okay. This is what I do. Right? And we can definitely try. Right? Okay. So let's call it a day now. I hope you enjoyed the session. And again, we are going to meet very soon with the next chapter, that is the kinematics. And for more questions, there are some PYQs questions I have come up with. So you can go there. Right? Okay. So shall we call it a day? So I hope that is. So guys, whoever is watching this video, thank you very much for watching. and I hope you enjoyed the video. In this video, I tried to complete the whole of this chapter in one go, and I think we have successfully done that. So this is going to be useful to you. Again, I am saying when you have done session once and you are revising it. So it is more beneficial when you have done it once from book or from anywhere from my lectures, and then you watch this video, particularly to some topics like vernier caliper and screw gauge. And for errors, you have to do questions beforehand. So with this, thank you very much. Please don't forget to subscribe the channel. Please like the video. Okay, and we can have more sessions like this. Okay. So thank you very much. Have a good day, and we'll see you in the next session.